Good morning from Japan. It is the second day of the NuttX International Workshop 2024, and we got quite a few people here in the room attending the presence workshop. And also we got Camila, the presenter from last year, joining us from Sweden. And near me we have Koizumi-san, which will run the workshop in person. So this is how the room looks in this moment. Hi, Koizumi-san. We are sorry for the delay. There have been a few organizatoric issues this morning, and we still have a few people that are delayed and will join us a bit later. But we are already late, so I think that it's a good idea to give the microphone to Koizumi-san and kickstart the day with the workshop. Please start.
Sorry.
You have to be unmuted.
Already.
Yes.
Yeah. So by using the neural network console, this one is recognizing the picture or displaying on the monitor, and there is a comment here, and Yeah, this recognition about 15 FPS is possible or achieved. Yeah, and resolution is like this. So, and pipeline inspection, the autoencoder. So um, uh, autoencoder. So there is a microphone there on the pipe, and the pipe makes us flow the air from the edge side. And if and now it's a normally, but if cover the pipe, then the anomaly is detected, and also the outside cover the same thing. Yeah, they're running data, so the FFT data running the autoencoder, so it can be anomaly detection, and of course the turn off the air, then it also can detect the anomaly. And after that, if the kind of the scratch rock on a click on a pipe, yeah. Now the detector anomaly things. So yeah, the persons can handle this kind of the audio things real time. By using the 6 cores. So next is object extraction. So binary semantic. And this one is this one detects the kind of the star things on here. So yeah, in this case, it's almost 1 FPS, and yeah, like this. And yeah, this one. Yeah, this one is a network structure for detecting this object.
They are all implemented on the TensorFlow, right?
Sorry.
So all the demonstrations are implemented with the TensorFlow, right?
Is it using TensorFlow Lite?
Online?
No, TensorFlow. Is it using TensorFlow Lite?
Now it's using the neural network console, the Sony's running system. Yeah, there is. You can use it on the website. And now is kind of speech recognition. So make the F50 and correcting the F50 with the timeline. So on the red line, you can see the red line on the beginning of the right side. That is kind of the image, and using the convolution network, it can be detect the voice something. And this one is the gesture control. And So here is the device using the IMU and wireless module for connecting to the PC and the battery. And this one is kind of the HID for the PC, with the PC. Yeah, now there are three gesture can detect. Yeah, running data like this. So it can cut the data on the gesture timing and run it. And this kind of the AI can be run in on a run process, and the other functions other than AI, as of course you can make a drone and there is the GPS on the board, so to make a drone, and also we have a high-speed AD converter. So um, and LTM board exists. So for example, the GPS is sent to the server, and the audio change, and another input is and mark for processing this and image sensor. Yep. This is a expressions functionality overview. Yeah. Thank you. Yeah, the promotion, the video is done. So, do you have any questions about the expressions? Then I will answer it. So, okay. Thank you. Thank you. So, okay, so this is just a promotion of the presents, and then next step, let's start workshop. Okay, sorry, let's start the hands-on. Of course. So, Camila, could you take over and start the setup on the until NSH?
Yes.
Thank you.
So can everyone hear me okay? All good with the audio? Give me some feedback. Okay.
The audio is okay.
Okay. And is everyone with their expression boards over there? So I'm going to assume everyone's with their presence boards, and I'm going to take you through the first steps that you need to take to set up your board and have it running. And then Koizumi-san will come again and show you some cool examples, and things that you can do with it. So for starters, I guess everyone has their laptops, and I want you to go into the website that has the instructions. I'm going to share my screen, but of course, it would be great if you also open it so, we can copy paste. Aline, how do I send links to them? Can you share?
Everybody has access to Jitsi, and they can take the link from here from the chat.
Okay, perfect. That's amazing. So I'm going to, what I did last year, and that really, really worked, was that we went through the build instructions step by step, and we moved to the other instruction once everyone was okay. And then if you have any problems doing the instruction that we're going through, then we have support on site to help you with it. So I'm going to start sharing my screen. This website contains the build instructions for NuttX to work for this presence board. So the first thing that we need to do is to make sure that we prepare our environment. So let me get a terminal here. And we're going to run the first command, which will install some packages that we need. So I already ran it on my side, and I want maybe some indication on site if that step is okay and if we can move on. Aline, is it possible to have your sound open so I can hear what's going on site, or do we need to have only one person mic open at a time?
Oh,
I'm sharing
Camila,
now.
you
Let me
Zoom in?
see if I can do something regarding the sharing. I'll come back in a minute. Okay, now everybody should see your screen. And the link is displayed also on the screen, so it will be easier for everybody in the room to see the link.
Perfect.
They should also be able to hear you in real time now.
Perfect. Okay.
Please wait, people are still opening the build guide.
No problem.
Did everybody copy the link? Okay, then we can probably go big. Can you see the screen?
Can you increase size? The size? No. I mean the terminal.
No, we are in Jitsi. On the terminal, the font size.
Oh, increase the font size on the terminal. Yes.
Yes.
I can do that. I actually don't know how to do that. Wait. Give me a second.
Control Shift plus or Control Alt
Perfect.
plus.
Not working. Control Alt plus, not working. Shift plus, nope.
Maybe the Control and scroll wheel up.
Nothing's working. I thought there was going to be like a preference here.
Yeah, go in the last option and change the size. Yeah, the name. You just copy the last option in the left.
I can hear it.
The last option.
Ah, perfect. Never had to increase the font. So spacing, make pressure shape, terminal bell, color, scrolling, command. Initial
Custom
terminal
fonts, and then
size.
you will be able to select the font size.
Okay. Okay. Ooh. Okay, let's try this. Is this better?
Yeah, great.
Perfect. Okay, so now that we're all with the link, so again, we're doing the setup, and let's all run together this sudo command to install some packages that we need. Let me know. Oops, I have my username. Wait. Yes, that's better. Yeah. Then let me know when everyone is done with this command, okay? Give me some indication that I can move on.
You need to fix to point it to the old website. It's to work, but yeah, it works. Yeah, so
Copy this one and then install those packages. Since you're on Mac, I think that you already have them, or your packages will be.
Well, it's stuff I use. So we have a better check.
Yeah.
I tried to get your machine, but it's so slow.
If you have access to a server, it's fine. You don't have to have it physical. So for the different versions, try to install it. I'll install the kickoff. Let's try.
Oh, you still have the machine? Oh, okay.
Try without That's fine. It's moving. Yeah.
Let's try some other
Let's see. Install. Okay. Then we have to tell camera. Okay.
How are things going over there?
It is still installing on most computers.
No problem.
The packages take quite a while, so let's wait a few more minutes and then we will tell you when everybody's done.
Perfect. Thank you for the support on site.
Okay.
Wait. So
Still
Already, everything was, I didn't install anything.
I just copied your URL on THF.
Yeah, thank you.
Maybe it's PC.
Did you manage to install?
Yeah. I've already installed
Just the first line. I mean, I will go step by step. Okay. We only do the first one. Yes. Did you manage to install the packages? Are you ready to proceed? Okay. We are ready to proceed, Camila.
Yay, let's go to the next part then. So here for the, sorry, there's an echo here. Now for the second step, we need to install our toolchain for, our compiler, our ARM toolchain. So here in the first part, we're just giving the appropriate permissions to our user and then creating a folder so that we can put our toolchain in there and extract it. So first we're going to start with the user mod command. So I'll do it here together with you. So this one should be super quick. Users, and then you put whatever user you have. Second command is just to create this login shell that knows that you are from this group. So that is su and then a dash and your user. Then we're making a directory called opt/gcc. And again, changing permission for that. And then we're creating a going into that folder called opt/gcc. So for this part here, let's do it together and let me know when you are ready to move on. This one should be fast. Nothing too big to install here.
No. Camila, can you
Yes.
hear my voice?
Yes, I can hear you.
Actually, we can't hear you.
No? You can't hear me anymore?
I can hear you both.
Yeah, you should be able to hear me. Nothing changed here.
Yep.
You can hear me? No sound.
No.
Who's sharing the screen right now?
It's me.
Camila. Okay. Works for me.
Everyone call, can you hear me? No. Audio is stopped.
Let's see what happened.
I'm not sure. Just
Looks
stop.
like the Japan side.
Camila, could you speak something?
Hello.
Yeah.
Hi.
So
Now okay?
programming. Yeah. So now I unmute my speaker, then I can hear you. So just a moment.
Okay, so should I repeat?
Yes.
Yes? Okay.
Oh, just a moment.
Okay.
Mm-hmm. Okay, please.
Yes? Okay. Then just to repeat, we're going to our second part of the instructions, and that is installing our toolchain. So in preparation to do that, first we're going to run the usermod command to give us proper permission. And then we're going to create a login shell that knows that we're in this group. Then we're going to create a directory called /opt/gcc. And then again, run these two commands for permission, and then go inside that folder. So this one should be fairly fast and straightforward. So let me know when everyone is able to do that and to go inside this new folder that we're creating. Also, maybe is it okay to turn the camera towards the people in the workshop so you can see everyone?
Sure, give me a few minutes and I will do it.
Mhm. Cool, thank you. How's everyone doing? Are we good to go to the next instruction? Is that a yes? Okay. Then moving on, we want to download and extract our toolchain. So we're going to specify our host platform. In my case, is this x86_64-Linux. I believe everyone is with a Linux computer, but if anyone has a Mac computer, then you would use, for example, Mac in that case. So we want to choose our host platform, and then we're going to curl to this link here so that we can download this GCC ARM known version 10.3. If you don't have the curl command installed, then you can do a simple sudo apt install to get that one, in case you get an error message saying that you didn't get curl recognized. And then after we download that file, then we're going to extract it in the folder that we are in, and that should be opt/gcc. So let me know when everyone has that toolchain downloaded and extracted. If anyone encounters an error message or isn't able to follow the instructions, please raise your hand so we know and we can give support.
Oh, okay. Yes, yes. So when you go down,
Are you done with the toolchain download? Should we proceed? Okay, Camila, please continue.
Yes. Then I want everyone to add the toolchain to your path. So with this other command here, right? So we're gonna echo export path equals to our file that we just downloaded /bin. So yeah, this adds the toolchain to our path. And then if everyone is done with that, we can proceed. And after adding that to our path, then we want to do a source source our bash rc file just to get this latest changes to our terminal. Then if everything went all right, then I can do a which arm. See, I'm doing which arm -none -eabi -gcc, and if everything was done correctly, then it's going to show the file that we just downloaded.
who is achieving under here? No. Oh. Okay.
Yes, can we proceed?
Former people, about former people is still installing. Yeah, so,
Okay.
yeah. Um, 50 minutes. Maybe I can do just one minute.
They need first the NuttX. They need NuttX first
Into
on the source.
Yeah.
That will also take some time. That's why I'm thinking that maybe we can download while the other ones are.
You can proceed with the NuttX download,
Okay.
and then we will catch up if the others are not
Okay.
ready yet.
Yeah. So let's go back to our home folder, and we're going to create. We're going to create and dir folder called NuttX, and let's cd into that. And then we're going to clone two repositories. The first is NuttX, incubator-NuttX, and the other one is incubator-NuttX-apps. So I will do the first one now with you.
Small correction. In that link, please remove incubator, and we will correct the web page. It's just NuttX without incubator.
Okay.
The incubator still exists.
Already growing.
Yeah.
So if during the cloning the source code to rate, you can use the --depth space 1. It's just one commit. The newest commit is downloaded. So.
That's a really bad practice.
Really?
Yes, because as a developer, you want to see the history.
Yeah,
and then you don't have it.
This one is just the other one. After that, you can fetch to get everything.
People will learn that that's a fast way. But for the future, when they try to do it, you just get the latest one. It defeats the purpose of it.
Yeah.
Okay. So for me, it was done cloning. So I'm going to move on to the second one, which is the apps. And then again, as Aline mentioned, we're going to remove the incubator dash part. And for me, it's done again. So if I do a ls on my folder, I see that I have two folders now, one called NuttX and one called apps. So when everyone is done cloning those two, please let me know. I'll give you a few more minutes to finish. Just so I have an idea, please raise your hand if you have finished this part. Yay! So I'll start talking about the next part. So for the next part, we're gonna compile our code. So to start, we're going to configure NuttX to have the configurations that we wanted to. So we want to go inside the NuttX folder. So I'm going to cd NuttX again. So just to be clear, I'm inside NuttX/NuttX. And here I'm going to run this command. So tools configure.sh. Okay, grep expressions. And here it shows me a lot of options for pre-configured expressions use cases or applications. So we see, for example, that we have the camera example, we have LTE example, Wi-Fi, audio. There are many options. So to start now, the most basic one, we're going to choose the expressions NSH. So because this will enable booting into the interactive command line, not shell. So I'm going to pass here as an argument to my configure.sh script. The argument is presence 2 dots and sh. So that was very fast. So my configuration is now written. The documentation always also tells me here that I can also customize my features, and that's with make menu config. Okay. So if I run make menu config, it's giving me an error because I'm splitting my screen in half, and it's saying that screen is too small. So let me adjust here the size, and I'll run again make menu config. So here I can see all the configurations that I can do. And what I wanted to do is that I want to go into application configuration. So that's the last one. And we're going to go into examples. And here into the examples, we're going to choose the most basic example, which is the hello world example. So to enable this, I press Y in my keyboard, and then I press the side arrow, the right arrow to go to save, and then I'll save my configuration. So to repeat that one more time, from the beginning, if we're inside make menu config, we can go to the last configuration, which is application configuration. Wait, someone said something. Yes, we are working on master. Okay, so application configuration, examples, and then we go all the way to the hello world example, and we enable that. Then we save, and then we can exit. So this is the step where we are configuring what we want. And to remind you again, in this case, we chose NSH, and we also chose the hello world example, just so we can see something happening when we talk to our board. So I get a thumbs up, so I think everyone is good. So now we build. In building, super easy, we just do make. If you want to speed things up, you do make with a dash and however many processes you want to run. So I'll just do make dash J. And in this step, if you have not configured your compiler correctly, it will complain. So if you're able to make, that means you've done everything right so far. So let me know if that worked okay for you too. Yes, I have a fast computer. That's true. Aline actually helped me pick it, so thank you, Aline.
You're welcome. Thank you.
So maybe show of hands who have done it so far. Little hands up if you're able to make. I see 2 hands up, so 3 hands up. Okay. So Aline, do you think I should wait a little bit more?
Yes, we have to wait a little bit more. Koizumi-san also managed to compile, so
Perfect.
Let's wait for the others.
No problem. So maybe show of hands if you got an error while doing the make command. One person got an error. So good. So then we.
A warning. We already discussed about it. Is fine.
Okay, so it wasn't an error. It was a warning. Okay, but your make was successful at the end. Good.
Same code, no errors.
Mm.
We're almost at the end, and then we'll soon see our presence board working. I see a lot of people talking. I love it. Love to see you interacting. Yes, it is 2:23 in Sweden. I have had a lot of coffee.
Did you manage to build? Do we have successful build?
Yes. Question on the chat. Was this presence chip we play right now used in the latest moon lander? And yes, it was the presence camera board. that landed on the moon and took a picture. So that was very, very cool.
We have one here in the room.
One what?
One lander.
Okay.
I can do a bit of show. So here is the lander.
Ooh,
And then here we
that's
have
so cool.
a lot of exoskeleton, a lot more presence. Then we have a small robot, maybe an IMU board. Also from Sony, we will have a demo on the channel later. Alan is supposed to film it today. So quite a lot of interesting things. And then we have an IMX 500 camera, I see here.
Ooh, I love it. That's so cool.
Yeah, you would have loved to be here and play a bit with all those cool things. Yeah, this is our lovely room.
Oh. Hey.
Yesterday we had up to 40 participants in person for the workshop. We will start again up to 1 hour.
30 minutes. First.
Yeah, is everybody ready? Do we have the NuttX image ready to be flashed? I think that we can proceed, Camila.
Okay, perfect.
Yeah.
So let's go to the flashing part. So now that we have configured our NuttX.SDK, we're going to flash it. So I want you to do this tools/flashwriter.py command. Okay, I will do. Actually, before we actually need to connect our presence ports to our computer. So let's do that. And I have no more USB ports available, so I'll put here. Yes. Now I'm connecting my presence to my computer. And when connecting, you should see a blue light here, indicating that we have power. Okay? So the Terminator. Okay. So just this would be this presence board. And now I have attached to it, I have actually a camera board. And I also have an extension board. This extension board allows me to have an SD card with my board. Okay. And let me connect again. Okay. So now that I have it connected to my computer and I have a blue light telling me I have the power, then I will now run this flash writer command. Okay. Now, there's one detail that is actually not in the documentation yet, is that your bootloader. So if your board is brand new, which I imagine yours are, then we need a bootloader, okay? So to do that, to flash the bootloader, we're going to use the same flash writer script, but we're going to need to download this presence firmware. And I'm going to put in the chat the link to the latest presence firmware. Oh yes, that's true. For your flash command, you might need to install Xmodem. So that would be pip install Xmodem. Thank you. That is correct. If you don't have Xmodem, you might have to. If you don't have PySerial, you also might have to do a pip install PySerial. So I want to make sure that everyone was able to run this flash writer command, because we're going to need it working in order to flash our bootloader to our board. So maybe show of hands if you were able to flash your NuttX.spk file. I see no hands. Then I'll wait.
Did you manage to flash the NuttX.spk? If you are able to flash, raise your hand.
I have one hand. I want to see more hands.
We
So
have
please,
3.
3? Okay. So please let us know what problem you had when flashing. Okay, so that we can move on to the next part. If you have already flashed, you can go to the link that I put in the chat, and that takes you to the latest presence firmware. Then you download that. You have to accept a license. You download that, and you can extract it. It's a zip file. It's a zip folder. So you have to extract that.
Okay, so who is not achieving the yeah, that will be okay. That's not. Can you put the days, such days,
You do need to accept a EULA to be able to download the latest firmware. Once you download it, then I want you to put that folder in the NuttX. Once you extract it, I want you to put it on the NuttX folder we are using. So let me show my here. I have NuttX, and then here in the NuttX folder is where we have the NuttX.spk file. So I'd like you to put this presence binary in the same file, in the same folder, sorry. So you see that here under NuttX, exactly where I have my NuttX.spk, I have my presence binaries version 3.2.0.
This is a general, but it just uses X model to download file. So it will be 0. Yeah, just change the part. Like build so you create you configure express and shell.
Oh, could you press the Python paste on the button?
And the reason that we cannot put the bootloader as a part of the NuttX source tree is that we really need you to accept the EULA when you're downloading.
But you can not change, of course, you can change the line, but you need to specify your so you
Are you already asked to
So maybe a show of hands again if you're able to flash using the flash writer command.
they use to be flashed. So that's why, yeah. Anyway, this stuff is only used for expressions.
So for those of you who have already successfully used the flash writer script, yeah, I know. Then what we're going to do now is that we're going to use the same flash writer script to flash two files inside here as presence binaries, okay? So I'm inside presence binaries v320, and then we want to flash loader.espk and also sysutil.spk. So I'm going to do this here. This is my files. This is my terminal. And then I'm going to have the same, exactly the same command as last time. But instead of NuttX.spk, I'm going to change it for presence binaries v320 flash loader dot espk. Oh, sorry. Did something wrong.
As I
Binaries v320. Maybe I need a license.
As you know, oh, it's okay. It's okay. Just this is
okay, it's complaining about something. So what I'm gonna do is I'm gonna remove loader and sysutil. No trick. You mean that I need to put here? No. Okay. So what I'm going to do is I'm going to take these two, and I'm going to put here in the NuttX folder, so that I only need to do loader.espk. What's happening? Ah, okay. That's my bad. Sorry. I was in the wrong folder. I did a test folder just to clone again because I had already cloned before. But then I put the file on my real folder instead of the test folder, so that's what happened. And then I'll do the same thing with this util.sdk.
Error message. No, sorry. Okay, let's do a oh, yeah, okay.
Someone's asking, what is the sys util part? I don't have much information on what exactly it is. I just know there are some files with some system utilities. But I can't give you a more specific answer than that. We have one person already inside. Yay!
Or just everything it's month yeah. So this platform can be handled.
If you already flashed everything that you needed to flash, then we're gonna talk to our presence using HycoCom and doing the serial port /dev/tty USB 0. And here I see that I'm inside my presence and I see the nutshell NSH. So inside the command, the terminal now, I can ask for help and I can see, ooh, that's ugly. Yeah, I can ask for help and I can see all the commands that I can use here. And within my built-in apps, you see that I have hello, which is the hello example that we chose. So if I write hello, then I see hello world. Amazing. That's the stuff that sent us to the moon. Okay.
Are you ready to take
over? Yes.
Thank you, Camila, for the introduction and the hello world example from the moon. And unfortunately, we started a bit late and we are running out of time. We have to finish and switch to the presentation part. So Koizumi-san will take over and continue with the demos while you can go to bed and take a really nice sleep. Thank you very much.
Thank you so much. I hope you guys have fun at the rest of the workshop.
Thank you very much. Thank you.
Yay! See you. Bye-bye. Thank you.
Okay, so I will take about the next step. So now you already done the basic the the building and installing. So now I will present some the functions of the expressions. And as Camila also maybe I should get more. Oh yes. Can you hear? Can you see? Yeah, much better.
Yes.
So I will introduce another configuration, but now we have just 40 minutes, so I will just introduce one thing, the audio functionality. So as Camila shows, now we have some default configuration. Config sh-l bar grep expressions. Then you can see expressions default configuration. Take time. Okay. Ah. Oh yeah, the audience.
So basically, now the tool will list all the configurations that are available in NuttX for all the boards, and then we will pick from those only the ones that are common for presence.
Oh yeah, now. So the these expressions the default configuration is now ready on NuttX. And today we will execute FMSynth configuration. So this one is kind of the FM synthesizer making the sound in the presence and playing. So let's start the configuration. So now the Camila explained the config sh just FM synth is good enough. No. Okay. Like this. And then it is configured. And these default configurations already are the FMC's example enabled. So just make after the configuration. And of course, don't forget -J for accelerate. Yeah, wait for a moment to build up the NuttX SDK. Mhm. Okay, now they build up in success. So after that, you should flash hyphen B. Hyphen C protect the TTY USB 0 NuttX K. Okay, start flash. And connect the terminal to the NuttX to the presence. Then you have two commands. One is the keyboard, one is the MML player. MML is a music macro language. It's very old, bit old specification before the MIDI. So yeah, and let's try that first keyboard. And then this key is related on the code of the music. So you can type like that. Yeah, so now just detect a key press and making the sound related on the key and just how's the sound play. And next, let's try to MMM player. So press reset on the bottom side of the presence, white button. Press this. Then you can see the reboot and the NuttX shell prompt again. And just press MMM player down. Right there. Little bit, how to say, なんて言うんだろう、破裂音ってなんて言えばいいんですか Yeah, like this. So this one is, how to say, kind of the MM prayer. Yeah, and the just let me just let me see the code. It's actually in apps, examples, and FM things here. And the music code of the MML is MML score.h. So now this code is MML code, and this one is just kind of score of the music. So you can, of course, you can do modify, or you can implement your music you like, of course. Yeah. Okay, almost it's left 5 minutes. So sorry, pushing you, but now, yeah, you have experience for build and flash, build the NuttX and flash to the presence and execute. So, yeah. Any questions so far?
Thank you, Koizumi-san, for the tech demo and the workshop on this presence board. And let's hope that the next time we meet, we can talk about having MIDI music from from Mars.
Mm-hmm. Yeah. Okay. But anyway, we have much more time, daytime after this handout. So if you try something and if you have come up with any questions, feel free to ask us. This is here. I can see. Ah, yeah. Um, I'm sorry, but your board will end. Please get back to on this level after. Yeah, thank you.
Alan, we are getting closer to the kickstart of the day on the presentation with the presentations. So Alan will join me soon.
Mm-hmm.
Tomac, can you switch to the schedule for the day? I see that we have a
Okay, hello everybody. Welcome to second day of the NuttX International Workshop. I am here with my friend Alin. And hello, say hello guys, and thank you everybody for coming here and also for watching us from YouTube. And let's start our first presentation today. Is about how to move from Linux to NuttX, how to port application. And let's start. I don't remember, it is pre-recorded, right?
Yeah.
Okay, so Tomek, could you please start it?
Hello everyone, this is Wang Bowen from the VAA team at Xiaomi. I'm happy to attend this year's NuttX online workshop. Last year, we did some works about the virtual I/O frameworks and did a presentation about it. Now, 6 months have passed. We have made some enhancements in API message and virtual I/O. This is also the topic of my presentation today. Here is the outline, which can be divided into 5 parts. The API message framework refactor, NuttX to LaTeX or Linux communications, virtual I/O PCI transport support, vhost framework support, and something about the future works. The first topic is the API message framework refactor. Before introducing the API message framework refactor, I would like to briefly introduce how the API message services use the API message API to send and receive messages, so you can better Hello everyone. Hello everyone. This is Wang Bowen from the VAA team at Xiaomi. I'm happy to attend this year's NuttX online workshop. Last year, we did some works about the virtual I/O frameworks and did a presentation about it. Now, 6 months have passed. We have made some enhancements in API message and virtual I/O. This is also the topic of my presentation today. Here is the outline, which can be divided into 5 parts. The API message framework refactor, NuttX to LaTeX or Linux communications, virtual I/O PCI transport support, vhost framework support, and something about the future works. The first topic is the API message framework refactor. Before introducing the API message framework refactor, I would like to briefly introduce how the API message services use the API message API to send and receive messages, so you can better understand why we need to refactor the framework. First, I want to ask what is the IP message? IP message is a message mechanism implemented on top of physical transport layer, such as the virtual SPI and UART, to communicate with a remote processor. Let's briefly describe the IP message usages. As shown in the left figure, IP message communication can be roughly divided into two stages: connection establishment stage and the communication stage. First, in the connection establishment stage, both the local and remote core call the IP message create endpoint to create an endpoint. The parameter name is used for the endpoint binding, and the parameter callback is used for receiving messages. Afterwards, the endpoints on both sides are bound based on the name, and both sides can send messages to each other. For example, if local core want to send a message to remote core, local core can call the IP message send to send a message to the remote endpoint, and the remote endpoint callback function will be called to process this message. Based on this mechanism, we can implement many useful IP message services, such as the IP message file system, the IP message socket, and the IP message syslog. So, why we need to refactor the IP message framework? The left diagram shows the architecture of IP message framework before refactoring. The top layer is the IP message services, which call native IP message API provided by the OpenMP library and the NuttX extended IP message API to achieve their own functions. And notice that the native IP message API is compatible with different transport layers by a well-designed port layer. But NuttX extended IP message API is highly coupled with the NuttX IP10 framework, and IP10 is highly coupled with the IP message virtual transport layer. So, the IP message services use the NuttX extended IP message API can only work with the IP message virtual transport. In order to make all the IP message services be able to work with all the IP message transport layers, such as the IP message SPI or UART, we have to refactor the IP message framework. So, how to refactor? Like OpenMP library does, we also introduce a port layer in NuttX IP message framework, and net the IP message transport layer to port 8. The IP10 framework is also modified to port the new IP message framework. As you can see in this figure, from the left to the right. Then, all IP message services can run without modification on top of any IP message transport layer. And this work has been upstreamed to the community. This is the pull request link. The next topic is the NuttX to NuttX or Linux communications. And first, I will introduce the IP message virtual-based communication. QEMU is a free and open source emulator. It allows the developers to test the software on a variety of different hardware architectures without preparing the physical hardware. And NuttX has been supported to run in QEMU for a long time. But unfortunately, the cross-core communication feature has not been utilized in QEMU. So, this feature can't be tested well in emulator environment. But now we have supported it. The left figure shows the architecture diagram of how two NuttX in QEMU communicate with each other. We have two virtual machines, VM1 and VM2, and both of them run NuttX. The green part is the IV shared memory client device, which is QEMU-provided PCI device to make two virtual machines be able to access the same memory in host OS. Based on this shared memory, we can implement the cross-core communication between two virtual machines. First, we implement a PCI IV shared memory driver in NuttX based on the PCI framework. Then, we implement the RP10 IV shared memory driver based on the PCI IV shared memory driver. After that, two NuttX can communicate with each other through the RP message. In addition, we also support the NuttX to Linux communication in QEMU, also based on the IV shared memory client device and the RP message virtual transport layer. As shown in the left figure, the difference is that the virtual machine 2 changed to Linux. Like what we do in NuttX, we also implement a PCI IV shared memory driver in Linux, and then implement a remote poke driver IV shared memory remote poke based on the IV shared memory driver. And more, we also support various RP message services not compatible with NuttX, such as the RP message pin, the RP message socket, the RP message syslog, the RP message file system, the RP message TTY, and the RP message sensor. Then, I want to introduce the RP message SPI UART-based communication. As shown in the left figure, in some scenarios, two chips on the same board need to communicate with each other, such as the Android plus the Atos dual system smartwatch solution. The two chips do not have the shared memory, so the RP message virtual transport layer can't be used. We add the new RP message transport layer, RP message SPI, and RP message UART in both NuttX and Linux to achieve this goal. Of course, all already implemented RP message services on NuttX and Linux can run on the new RP message transport layer without any modifications. The diagram on the left shows the architecture of RP message SPI and RP message UART. Both in NuttX and Linux, the RP message SPI and UART are based on the existing driver frameworks. And we already did some tests on our platform and achieved good results. The right side shows the results with RP message pin. With the RP message SPI transport, the transfer speed is around 9.3 megabits per second and achieved 77.5% of the maximum theoretical speed. And with the RP message UART transport, the transfer speed is around 80 kilobytes per second and achieved 87% of the maximum theoretical speed. Then, the next topic is the virtual PCI transport support. Last year, NuttX has supported the virtual framework, various virtual drivers, and the virtual MMIO transport layer. This page shows all the pull request links about the virtual. Thanks for the contributions. Yes, virtual MMIO is a very friendly and commonly used virtual I/O transport layer for embedded system. But unfortunately, some hypervisors do not have good support for the MMIO transport layer. An example is that the Archon hypervisor only supports the virtual I/O PCI transport. We can know this message in the official documents. So, this year, we add the virtual PCI transport layer support based on the PCI framework. The diagram on the left shows the flow about how virtual I/O PCI devices register to the virtual bus. First, the virtual PCI transport layer is a PCI driver and of course will be registered to the PCI bus. Then, the PCI controller scan all PCI devices and also register them to the PCI bus. For every virtual PCI device, the virtual PCI driver pop function will be called to initialize the virtual device and register the virtual device to the virtual bus. Finally, the already implemented virtual drivers, the pop function will be called to drive these virtual devices. This is how the virtual PCI transport works. And then the fourth topic is the vhost framework support. First, I would like to explain why we need the vhost framework. Now, the virtual drivers in NuttX can only be used in hypervisor environment with the virtual I/O, MMIO, or PCI transport layer. However, we also want to use the virtual drivers in a cross-core communication environment to improve the cross-core communication performance. This is why we need the vhost framework. As you can see in the left figure, in hypervisor environment, the virtual drivers are implemented in NuttX and the virtual devices are implemented in hypervisor. They communicate with each other through the MMIO or PCI transport layer. To make virtual drivers be able to work in hypervisor-less environment, we should implement the virtual devices framework in NuttX like Kummer does, and we call the new framework be vhost framework. This diagram shows how the virtual drivers used in cross-core environment. The main CPU can access the physical device in the remote core through the virtual and the vhost framework. Let's start from the main CPU. The existing virtual framework and virtual drivers do not need to be modified, but we should implement a new remote POC transport layer. The overall framework of the slave CPU is similar to the main CPU. The difference is that the virtual I/O framework becomes the vhost framework, and the virtual driver becomes virtual device. And both sides require the remote POC transport layer support. We have implemented the vhost framework and some simple virtual device, such as the vhost RNG. But more virtual devices and the remote POC transport layer support are still in developing. The next topic is about the future works. In summary, our future works contain two parts. First, we need to implement the remote POC transport layer for virtual drivers and virtual devices. Then we can use the virtual drivers and devices in the cross-core communication. Secondly, based on the first point, we can implement the virtual socket. Then we can use the vSoc address family to communicate with the Linux. That's all. Thanks for listening.
Go.
Hello, it's a pleasure to be here. Well, there is already a lot of people talking about QEMU, so I will make the QEMU part fast. I want to present Renode, which is another possibility, and we also will go through the current state of emulation support in NuttX. So, well, I will present a bit about myself and explain why do we need this, what is the current status, and then there will be two quick demos. The first one is just the ESP32 QEMU, and the other is a quick Renode demo. So I have some experience with embedded software, but mostly other RTOS. I am new to NuttX. I have started using this about 2 years ago. In about 1 year, I started to push some PRs, and I am experimenting with the ESP32 and ESP32 S3 NuttX part mostly. As you can see, I am top 85 NuttX contributor, so you need to zoom in to see, right? So, well, I work for Midokura. Midokura is, in Japanese, it means green cloud. And we are part of the Sony group. We develop edge AI software with WASM. And our app, it runs on the same code base, runs on Linux and NuttX. So this is just my own view. So Midokura or Sony might not share the same vision as I do. So if you have any question, please ask to me. Don't go bother them, right? And well, why do we need device emulation, right? SIM is not close enough to real life scenario. We'll talk this on the next slide. We want to test applications on different hardware, possibly in the CI, and then testing on real devices is costly and difficult. And sometimes the real device is not ready or available, but we still can do parting in development. In Midokura, we like to make all the CI, all the testing automated, and we run WASM workloads. We're developing a system that orchestrates WASM workloads on microcontroller devices. And we want to be able to test everything in the real ESP32 device. But as I said, it is difficult and costly. So we are implementing these kinds of emulation to be able to run ahead of time compiled WASM modules on our testing. So I think a good example is the RISC-V ecosystem. Before the chips started to come out, they had already the Toolchain and everything developed, and that was because the emulators and the ecosystem is already pretty mature. And well, so why not SIM, right? We use SIM also, but SIM have many limitations, right? It is good for application development. It's very fast, very easy to debug, but it only works on host architecture. So, well, no ESP32, no ARM, right? Well, you would need an ARM computer. There are no interrupts. There is different context switch. The network support is really awkward. We either use TuneTap, which requires privileges and set up networks in the host, or we use VPN-Kit. VPN-Kit is a dead project. It's been years without any contribution. I think Docker uses it under the hood for Mac OS, Docker desktop. But apart from that, I don't know anyone that is doing any meaningful use. If you check their GitHub, Mob VPN-Kit, it is installed. I think the last commit is from more than 1 year ago. The CI is broken. It is using broken dependencies. It doesn't support ICMP. So, well, I could talk 20 minutes about why VPN-Kit is not good enough for any of us. And well, ToonTap is much better, but it is we still have the same limitations as in SIM. And the most problematic issue with SIM is that the network is done in the idle loop, so there are no interrupts. So all the problems that we might get related to race conditions or deadlocks in the network, they cannot be reproduced in SIM. So, well, it's very different than the real life, right? And also there are no real peripherals. There are no way to test drivers. So if we want to test drivers, we're going to need to mock up everything. And well, that's not a good way of doing this. There are much better ways. So well, there is QEMU and TinyEMU. I'm sure everybody here has much more experience than me with those. These were developed by this very smart guy, Fabrice Bellard. Is the same guy that developed FFmpeg. He's like a hero in software development world. But this usually requires some special build configurations. It's not the same firmware that we run in the final hardware. So the real hardware is different. There are peripherals, the clock systems are different. So well, normally we need a special build of NuttX with some tweaks to work on QEMU. The good about QEMU is that it has many platforms, and it's a very mature and complex project. It also provides very easy network setup, like we can use ToonTap. There is user networking, which is like VPN-Kit, but without VPN-Kit, and it supports ICMP, as I'm gonna show. And it is also easily extensible. And then the same guy created this TinyEMU. This is really small and simple and fast project, but it only works on RISC-V and x86. And I don't think there are any plans on supporting all the platforms that QEMU supports, for example. So we have QEMU support in ESP32 NuttX, but there was no network for it. So there are two options for doing this. We can use the official expressive QEMU, which does support open cores, Ethernet. It's like a, how can you say, this is not real present in the real ESP32, but it is like a open source Ethernet IP core that is implemented in QEMU. So as I said, the firmware that we run in QEMU will not be the same that runs on the real device, because we need to enable this this Ethernet driver that is not available in the real device. You just need to enable these two options, and well, there is this def config if you want to try. There is another option. There is this other QEMU from Ebero. This implements a Wi-Fi emulation, so it's like QEMU runs a Wi-Fi access point, and then you could just run the real firmware with Wi-Fi client on ESP32. But this is not really reliable. Sometimes it breaks, and well, I don't know why. I didn't have time to investigate. So what I did, I contributed this PR to NuttX, adding the open cores network drivers. There is not a big deal there. I just shamelessly copied from ESP-IDF, the implementation, and put in NuttX. And I'm gonna show now it working really quick. Well, I have already built NuttX, right? And well, this is the command, right? So basically, this is not necessary. I'm just setting the if use so NuttX doesn't complain about the version. I have the merged binary, which already includes the bootloader and the partition table and everything. And then here is the Ethernet driver. So if I just run this, well, it is there. I can even do some ICMP. Well, this is impossible with SIM, right? And it was also impossible without this last PR. We can quit, we can open, oh wait. we can get to the QEMU terminal, and well, we can do snapshots, and well, QEMU is very powerful, as you know. The other option that I think it's really interesting is Renode. Renode is a huge project. This was developed by NTMicro, which are some very smart people. They are RISC-V pioneers. So they mock up most of the real hardware, and not just the CPU. They mock peripherals and the full board. There is a very steep learning curve. The documentation is increasing. The quality of the documentation is increasing very fast, but it is still very difficult for a new user to start using this. But I really recommend anyone interested to start exploring. There are many architectures supported. There is no ESP32, but there is this Extensa sample controller that is, I have it here. So the Extensa sample controller is like, as you know, Extensa, they are now part of Cadence, right? They sell the IP core, so you can build your own CPU, and Espressif bought the IP core and made some customizations. So if you buy or you download the trial versions, you can just open this sample controller, and this is almost like the ESP32 CPU with many missing features. Zephyr already has support for this. This also builds the toolchain, the GCC. So, this is one architecture that I wish we could port NuttX to, and it would not be too difficult. So it is easily extendable with new SoCs and peripherals, and this runs the real final firmware binaries. So they normally use Zephyr. They Renode guys, they really like Zephyr, and they're really close to the development.
They are not so smart as you.
Yes, well, they need to open their minds, right, and start to run NuttX. I think they will be glad if we start to contribute some scripts and things to increase the support, right? This can be used for driver testing. We can even create some theoretical SoCs with some peripherals that don't exist. It has deterministic execution, like we can emulate multiple boards in the same configuration, and then just step time, pause time, make snapshots, save, restore state. So whenever we have a crash or anything, we can just like save the state, zip everything, send over the internet, and have someone reproduce. It also has many more goodies that some of them are documented, some of them are not. But well, this project is awesome. For this to work, I am gonna use the STM32F7 Discovery. If we check here on their website, there are many supported boards. I'm gonna use this one, right? The Discovery. There are many other in Renodepedia. There are many other boards, and as you can see, these are like full boards, not just the CPU. So all the peripherals, well, not all, some of the peripherals are there. If they are missing, we can add it. So for example, this Z board external, so they have here the LEDs connected. There is a PHY connected to the Ethernet. And in the STM32F746, which is the chip used in the Discovery, you can see here that the configuration of this. So basically, this is a mirror of the memory map that you can find in the technical reference manual. For some reason, it looks like Zephyr does not use this part here, the ITCM RAM, so it is not necessary, but NuttX just put a heap here. And I needed to add these two lines, otherwise I would get some warnings and, well, of course, assertion error because the heap was not working. So this I just put like some mapped memory that in the system bus at this address. You see that the address matches the beginning here. I put more size here than only the ITCM RAM because I don't really care about this stuff. So I just, well, it doesn't really matter, right? We will not try to write to this, But if we try to write, it's just like a memory mapped memory. So we can just write and read. If you read from an address that you wrote before, the data will be there. So I'm using this def config here. I needed to enable this use base pre. Otherwise, when there is a context switch, I think NuttX was generating this. NuttX was depending on a hard default to do the context switch, and for some reason this didn't work in this emulator. So, well, after a lot of headache, after enabling this, it worked. I also added many other goodies there: telnet server, telnet client, IP configuration. And then this binary that we build here works on the real board with no modification. So I will show here two scenarios. The first scenario is just I get one discovery board, I enable the display, enable the word, I load the binary there, and then we just reset the board. So So as you can see here, we have the display, we have the word. This is the real word, right? So whenever it writes a character to the word, we get it. So when I start, you can see I have NuttX with many stuff, and well, I could run OS test. I will just start again. I will not wait for this to finish. I will also run one of these NX demo or NX lines just to show that the display works, right? So, okay. The other demo I'm gonna do, I will run two devices, connect them to a Ethernet switch, the Mac. I don't need the PHY, it's just like the Mac is directly connected to the switch. And then I will access the, this will be automated, right? So from the word of the second device, I will telnet into the first device, echo something in the word, and then start OS test. Well, OS test is not finishing through telnet, but this is a separate problem, right? So let me show the script first. So I have this script here. So basically, I am starting the other script that just creates the board, creates the switch. So here there is an Ethernet switch. I load this binary here, connect this to the Ethernet switch, and then, well, the same one on the other one, I connect to the switch. And then I made this test script. So basically, I'm starting the other one, and I sleep for 5 seconds. Then I go to the word on the second device and do telnet, right? Then I wait another second. I do echo, sending to the word. So you will see this message on the first device word. Then I sleep 4 seconds and do OS test. I will not wait for OS test to finish. And as I said, it will fail for different reasons. So maybe later we can debug why OS test doesn't work over telnet. So here it is. We have the first device and the second one here, right? And you see with telnet there, we echo. Now we are waiting 4 seconds, and then OS test started. So, well, everything can be automated, and of course, it includes a GDB server, so we can connect through GDB and debug. And I did not make specific tests, but I feel that this emulation is a bit faster than the QEMU emulation that was running on the same device. So finally, I want to request help of the NuttX community. These are in my to-do list. There are more things in my to-do list, but these are the real urgent stuff we need. So first, I think it would be nice to have this sample controller part in NuttX. It requires this obscure GCC toolchain that from Extensa. You can find it in Zephyr, so we can just harvest from there. I also want to provide some working scripts for running scenarios and developing on Renode. We need to test other architectures. For this demo, I just did ARM, but of course, there are many others, right? Improve the documentation. And this is the most important. I beg for the NuttX community. We should start to do some application testing in NuttX CI. So we don't just verify that the build works. We need to provide a quality assurance gate that we can be sure that most or all of the default builds probably work out of the box on the real hardware. And of course, this is impossible to do with the real hardware. We would need a building full of boards just to test the NuttX, all the NuttX parts, right? So if we do this using QEMU or Renode or anything, we can increase the quality, increase the, well, improve the documentation. So I want to thank you all. Thank you for NuttX. It's a great project. I want to especially thank Alan, and Alison for organizing the event. And well, when if anyone wants to discuss this further, I am around. I'm also around on NuttX Discord. Thank you.
And also Tomek, that is in the
Yes, Tomek.
Sorry.
Thank you, Tomek.
One comment, and then we go to the Q&A session. I would suggest that instead of posting this kind of question on Discord, or offering support on Discord, where you have a limited number of developers,
yes,
I would suggest to send an email to the dev mailing list proposing this kind of setup, and then we have more people that will be able to say what they think about it. I really like it. I would personally think about setting up a test environment in my house. I have a machine that can run it. And then we can do daily builds and test all configurations that are there. That is something that I can provide outside the project.
Nice.
But at least we would make sure that things are in a workable state. For the CI, if we have to test for each commit, all platforms and all configurations, we will get that test done in days. And that's not something that probably most people would want. But if we can have weekly snapshots, and we know that everything that we got until a point works as it should, then even if we have a regression, it would be quite easy to bisect and see where the problem was.
Yes, I agree.
If there is interest on the dev mailing list, I will set up this this kind of automated testing.
On the real board or on emulated environment?
On emulators, but for all boards. Real boards, having 300 boards, it's a bit hard.
Yes.
Yeah, I think about the board. Some time ago, the guy, Brennan, create a list where people put which board they have. So maybe you can decide, for example, I can test that board and other.
It's harder.
Yeah.
Because then I agree that splitted workload is nice, but then centralizing the data will be quite hard. While if we do an emulator test, even though it's not real hardware, you get them all from one machine in one file that can be accessed by everybody available on GitHub. So the machine can test and push the result on GitHub. Then you have a file.
Yeah, but about the test, even the emulation that you said can delay days. The Linux BIOS project, more than 15 years ago, they used distribute between many developers. And they have a website that collects that information, show if pass or not.
We are not there yet. So this I think
we will get there.
Would be the best approach for now.
Anyway, please submit an email to the dev board so
Yes.
that we can all discuss.
Mhm.
We have to remember that this conference is covering only some of the project members.
Mhm.
Others will watch the event later or they will not watch it at all. It's
Mhm.
their choice. But we have to have a consensus on the
Yes,
mailing list.
yes.
Otherwise, I don't think that is fair for the others.
No, yes, I will collect this information and prepare an email and send there.
Having a proposal there would be good, and then we can also check with the Apache tooling maybe, if they can provide some infrastructure under the Apache project. So there are many ways of doing it, but I think that it's better to talk with the whole community instead of just a small group.
Yes, I agree. I'm just bringing the subject the first time here, but of course we need to share with everyone.
Thank you very much.
Thank
Sorry
you.
for jumping in. Are there questions in the room? Are there questions on the web?
Actually, I have one question. You show many options there, including the TinyEMU.
Yes.
Did you have play with it to do some compilation because it's smaller and faster than?
No, not with
I
NuttX.
suppose it's
Yeah.
faster than KEMU and even Renode, right?
Yes, I think so. And I think even Renode can use QEMU or as a backend and probably TinyEMU also. So we could easily get ESP32 support in Renode more or less.
Yeah.
So I didn't play enough with TinyEMU. I'm working more with Renode and QEMU.
Great. Cool. So,
Super. Thank you very much. We don't have more questions in the room or on the web. So I propose that we proceed to the next presentation, and then we keep this pace, and maybe we gather a few minutes for lunch. We will see, and we will do the same for the evening. So can you please?
Hello everyone, I'm Yue Xinyi from Xiaomi VAA. I'm very happy to be a part of today's online workshop. My topic is Introduction to Xiaomi VAA Emulator. My sharing has three parts. First, introducing architecture of Xiaomi VAA Emulator. Second, introducing supported features of Xiaomi VAA Emulator. At last, introducing application scenarios. As we know, NuttX and VAA already support simulator, so why do we need to develop an emulator? What are the differences between an emulator and a simulator? For simulator, currently host OS only supports Ubuntu. VAA for ARM only run on Ubuntu for ARM. VAA for x86 only run on Ubuntu for x86. For emulator, the host OS supports Ubuntu, Windows, and Mac OS. Emulator can simulate the host OS hardware environment and CPU instruction set. So, guest OS can run on different hardware architecture of host OS. For example, VAA for ARM can run on Windows for ARM or Windows for x86. VAA emulator is developed based on Android Goldfish. Let's introduce Android Goldfish first. Android Goldfish is based on the Quick emulator. Google added Goldfish pipe and utilize it to define and implement many drivers, such as firm buffer, input, sensor, and camera. Additionally, Android Goldfish has made some custom modifications to the Quick emulator. And VAA emulator is developed based on Android Goldfish. We implement many standard virtual driver and Goldfish drivers. In addition, we also made some changes to the Goldfish core to make our emulator not only run VAA but also can run Android. Let's start the second part, introducing supported features of Xiaomi VAA emulator. This is the architecture diagram of VAA emulator. The development of virtual drivers and Goldfish drivers is the most significant workload in developing VAA emulator. Currently, we support almost all standard virtual drivers and support important Goldfish drivers. Currently, we support 3 processor architectures: ARM v7A, ARM v8A, and x86. We have implemented many virtual drivers and Goldfish drivers, so our emulator supports a wide range of features, including graphics, audio, camera, Bluetooth, network, telephone, and more. Let's start the third part, introducing application scenarios. Because the emulator have debugging tools like GDB and Kaizen, development and debugging efficiency is increased. Moreover, we use emulator to check the usage of resources, such as memory and storage, in advance to reduce project risk. Currently, many of Xiaomi's products can run on VAA emulator, such as Xiaomi Watch, Xiaomi brand. Let's watch a demo video of Xiaomi Watch usage. In the video, there are 3 usage scenarios. First, pair and band with a phone with Bluetooth. Second, play online music. Third, a weather app synchronize information with the phone. Let's play the video. Pair and band phone. Play music.
He's really bad at numbers, but he doesn't like the odds. He doesn't like to run. He doesn't. I'm unstable. I don't want anyone thinking that I'm still not able. Lady, happier now. Been moving on. I just waited legs.
Let's watch a demo video of emulator being used in an IDE. This demo video shows 2 features. First, debug JS applications with breakpoint. Second, the hot update features, which allows for real-time viewing of modified effects. Let's play the video. Set the breakpoint. Change the text. Update the text. Okay, that's all we have to share today. Thank you.
Hello everybody, I'm Lup from sunny Singapore. In this presentation, I shall talk about a fun new emulator for Apache NuttX RTOS, the TinyEMU RISC-V emulator. If you would like to download the presentation slides, please head over to this link, lubyuan.github.io/NuttX. That's the letter L, not the digit 1. My presentation, transcript, articles, and source code are available at that link. What if we could boot and test NuttX inside a web browser? Today, we shall talk about the TinyEMU RISC-V emulator that runs in a web browser, how we ported NuttX to the emulator, and how we customized TinyEMU to emulate the aux64 single board computer by Pine64. TinyEMU is super helpful for running our daily automated testing of NuttX on aux64. We will find out how it works. How did we make NuttX run inside a web browser? Let us explore the internals of the TinyEMU RISC-V emulator. TinyEMU sounds like a tiny flightless bird, but it is actually a bare-bones RISC-V emulator for 32-bit and 64-bit RISC-V. It runs in a web browser thanks to WebAssembly. And yes, TinyEMU runs Doom. And since it runs Doom, what about NuttX? Can we boot NuttX inside a web browser with a little help from TinyEMU? We are looking at the live website for Apache NuttX RTOS. Click the link for online demo, and we will see NuttX booting right inside our web browser, all thanks to WebAssembly. This is a great way for anyone in the world to experience NuttX for themselves, right within their web browser. And yes, OS test works great too. This is proof that NuttX runs incredibly well on all kinds of devices, including web browsers. The demo we just saw is live on the Apache NuttX website. Try it here, or head over to the NuttX website and click Online Demo. How did we make this work? In this presentation, we talk about the HTIO console that is natively supported by TinyEMU and how we modified NuttX to support it. This is the Berkeley Host Target Interface, HTIF. For console input, TinyEMU supports Virtual I/O Console. We switch on the NuttX driver for Virtual I/O Console, which calls the OpenAMP library for I/O messaging. This is for Open Asymmetric Multiprocessing. Then we compiled everything from C into WebAssembly with the Enscripten compiler. Why are we doing this? Well, it is kind of fun to watch NuttX run inside our NuttX website. Like they say, eating our own dog food. Later, we will talk about emulating a real RISC-V single-board computer. This is the aux64 BL808 SBC by Pine64, which is super helpful for testing new NuttX apps and NuttX drivers. Maybe someday a NuttX dashboard that lights up and blinks in real time as the various NuttX drivers and NuttX apps activated. We could have done this in QEMU Emulator, though it is a bit too complex to customize. TinyEMU is tiny, easy to modify, and runs in a web browser. To prepare TinyEMU Emulator for modding, we download the C source code for TinyEMU, and we do the make. That is all we need. There is a demo of Linux booting on TinyEMU in case we need to figure out the internals of the emulator. We begin by customizing TinyEMU for the command line, then compile everything to WebAssembly later by calling the mscripten compiler. We begin by setting the RISC-V system memory map in TinyEMU. TinyEMU is hard-coded to run at these RISC-V addresses. Yep, it is a very simple RISC-V emulator that doesn't have any fancy configuration files. We take NuttX for QEMU emulator for 64-bit RISC-V. We see that NuttX is already configured to boot at address 80 million hex, so no changes required to run on TinyEMU. How do we actually boot NuttX on TinyEMU emulator? We create a TinyEMU configuration file, which will start the 64-bit RISC-V emulator and boot it with our NuttX kernel. We try booting NuttX in TinyEMU, but nothing happens. Well, it didn't crash TinyEMU, which is a good thing. Remember that TinyEMU uses HTIF console, which NuttX knows nothing about. Let us teach NuttX to print something. NuttX is actually booting in TinyEMU emulator, but we can't see anything because NuttX doesn't understand how to print to the TinyEMU console. Let us help NuttX now. TinyEMU supports HTIF for console output. This is the Berkeley host target interface. HTIF comes from the olden days of the RISC-V Spike emulator. HTIF is a UC Berkeley standard, not a RISC-V standard. We don't see it much in other emulators. TinyEMU source code is surprisingly readable. Here is the code in TinyEMU that handles HTIF commands. To print the digit 1 to the HTIF console, we set the device to 1, command to 1, the buffer to 31 hex. We write this long value to the HTIF register located at this address, like this. Now we understand how HTIF console works. Let us print something in our NuttX boot code. Our NuttX boot code is in RISC-V assembly. Thus, we write this RISC-V assembly code to print to the HTIF console in TinyEMU. And we see 1, 2, 3. Yay! Indeed, NuttX is running on TinyEMU emulator. Okay, our NuttX boot code is printing something in RISC-V assembly. What about the UART driver in NuttX? Can we print the boot log and crash dumps? Remember we took NuttX from QEMU RISC-V, which runs on 16550 UART driver. Let us do a tiny tweak so that we will see something in TinyEMU's HTIF console. We patch the 16550 UART driver like this to make it print to HTIF console. What happens when we run this? We see NuttX booting OK on TinyEMU. Here is a NuttX boot log. But NHH shell doesn't appear. Why? Because NHH shell is a NuttX user space app that needs proper serial I/O with UART interrupts. In NuttX, serial output is buffered. It needs a UART interrupt to flush the buffer, which means NuttX will fill up the output buffer, wait for the transmit complete interrupt before sending more output. However, HTIF console doesn't support interrupts. Thus, we upgrade to a proper console with interrupts, Virtual I/O console. We have been doing console output with the HTIF console in TinyEMU. Won't it work for console input and NX shell? Well, HTIF console supports polling of input and output, but it doesn't support interrupts. HTIF console is kind of bare bones, a bit like OpenSBI console. Polling only, no interrupts. To do proper console input and output with interrupts, we need Virtual I/O console. What is Virtual I/O? Virtual I/O is a standardized interface that allows virtual machines to access consoles, storage devices, and network adapters. And it works with TinyEMU. Somewhat like RISC-V semi-hosting, but a bit more sophisticated. What about Virtual I/O on NuttX? Good news! Virtual I/O is already supported by NuttX. NuttX provides Virtual I/O drivers built with the Open AMP library. That's the library for Open Asymmetric Multiprocessing. Open AMP provides the message queue library for Virtual I/O guests to call Virtual I/O hosts by sending device messages. In this diagram, Virtual I/O guest is NuttX, and Virtual I/O host is TinyEMU. OpenAMP sits in the middle. Now, how do we make NuttX talk to Virtual I/O in TinyEMU? We look inside the TinyEMU source code. We see that TinyEMU uses these addresses for Virtual I/O. We copy these Virtual I/O settings to NuttX. With these settings in NuttX, the Virtual I/O drivers and OpenAMP library will start correctly on NuttX. This says NuttX has validated the Virtual I/O magic number from TinyEMU, otherwise NuttX will halt with an error. Yep, NuttX has detected the Virtual I/O console in TinyEMU, and the Virtual I/O device is 3. The NuttX Virtual I/O driver is talking OK to TinyEMU. Let us send some data to Virtual I/O console. To do that, we need 2 Virtual I/O queues, the transmit queue and the receive queue. This is how we create the Virtual I/O queues in NuttX kernel. Transmit queue and receive queue. We will message these queues, which will print to the console. But isn't there already a Virtual I/O console driver in NuttX? Yeah, NuttX has a Virtual I/O serial driver, but we will do it ourselves anyway, so we can learn the inner workings of Virtual I/O and OpenAMP. To print something, we send a message to the transmit queue, like this. Our code prints successfully in TinyEMU. All these virtual queue functions, they come from the OpenAMP library. So Virtual I/O in NuttX is tightly integrated with the OpenAMP library. Now we understand Virtual I/O and OpenAMP a little better, we can switch back to the Virtual I/O serial driver that is already in NuttX. We are almost done with NuttX for TinyEMU Emulator. Here are the remaining bits that we completed. We switch over to the official NuttX driver for Virtual I/O serial, which will support console I/O with interrupts. For RISC-V interrupts to be triggered correctly, we set the PLIC address in NuttX. That's the platform level interrupt controller. We will keep the HTIF console, but only for printing debug messages during NuttX startup. There is something odd about RISC-V interrupts in TinyEMU. Somehow, TinyEMU won't let us enable MEIE, machine mode external interrupts. Our workaround is to enable SEIE, supervisor mode external interrupts. Then we patch the NuttX exception handler and map the interrupts from supervisor mode to machine mode. Nothing appears when we type in NH shell. Why? That is because we haven't enabled the echoing or key presses. Here is the fix. This will echo all keys pressed, and if the key press is carriage return, convert it to line feed. With these final few fixes, NuttX boots on TinyEMU emulator all the way to NSH shell. We compiled TinyEMU from C to WebAssembly with the Enscripten compiler. Today it is live on the Apache NuttX website. Try it here or head over to the NuttX website and click Online Demo. We haven't upstreamed the TinyEMU port to NuttX mainline. Let me know if you can help. This is a fun, impactful way to create something useful that anyone in the world can use by clicking the Apache NuttX website. If we look back at NuttX for TinyEMU emulator, we tweaked NuttX to run on TinyEMU, which is kind of backwards. Why not tweak TinyEMU to emulate a real NuttX device? Then we can run NuttX on TinyEMU without any changes. Now we talk about TinyEMU emulating a real RISC-V single board computer, the AUX64 SBC by Pine64, based on the Buffalo Lab BL808 SBC. This means we shall port NuttX for AUX64 directly in our customized TinyEMU emulator without any changes to NuttX for AUX64. We have a huge presentation on NuttX for AUX64 SBC. Please check out the presentation at this link. Today we shall chat about emulating the AUX64 SBC with a customized version of TinyEMU emulator. Here is a quick peek of AUX64 emulator. It runs the same way as the TinyEMU emulator on NuttX website, except that we customize TinyEMU to emulate a real AUX64 SBC, and it will boot NuttX for AUX64 without any modifications, which is a terrific way to test new NuttX drivers and apps. Now we go into the details, how we customize TinyEMU emulator to emulate a real AUX64 SBC. First thing we tweak in TinyEMU, the system memory map for AUX64 SBC. TinyEMU is hard-coded to run at fixed RISC-V addresses. Thus, we change these addresses to match the Buffalo Lab BL808 SoC. This part looks similar to the earlier slides, but instead of tweaking NuttX to run on TinyEMU, now we tweak TinyEMU to run NuttX. See the difference? The TinyEMU boot code is located at this address, 10,000 hex. It jumps to the NuttX kernel at startup. We will customize this for AUX64 SBC. Remember that TinyEMU supports Virtual I/O console. This won't work with the AUX64 SBC. TinyEMU needs to emulate the BL808 UART controller inside AUX64. We dig around the BL808 SoC and we discover these UART registers. We write to this UART register to print a character to UART output, and we read this UART register to check if UART transmit is ready for more output. This means that TinyEMU needs to intercept these UART addresses to emulate the BL808 UART controller. Inside TinyEMU, we intercept all reads to this UART register address and writes to this UART register address. That is how we pretend to be a UART port. More details coming up. This is the address of the UART status register. NuttX will read this UART register to check if UART controller is ready to transmit more output. In TinyEMU, we intercept all reads to this address and return the value 32. Why 32? That is the UART buffer size for BL808 SoC. It sounds simplistic, but it works for now. This is the address of the UART output register. NuttX will write to this UART output register to print a character to UART output. In TinyEMU, we intercept all writes to this address and we print the character that's written to the address. Don't forget the UART interrupts, which will be managed by the PLIC, Platform Level Interrupt Controller. To handle UART interrupts, we emulate these UART registers. UART status register should say there's UART input. UART interrupt mask should return 0. UART clear interrupt should clear the interrupt. UART input should return the key press. And we are done with UART. When we boot aux64 NuttX on TinyEMU, we will see the UART interrupts handled correctly by the platform level interrupt controller. TinyEMU boots NuttX in RISC-V machine mode, but we need TinyEMU to boot in RISC-V supervisor mode. Let us figure out how. What exactly is this boot code in TinyEMU? Think of it as BIOS for booting a computer. TinyEMU needs a tiny chunk of RISC-V machine code that will jump to a NuttX image in RISC-V machine mode. This won't work for aux64. We will find out why. TinyEMU is a bare-bones RISC-V emulator. It boots in only one mode, RISC-V machine mode, which is the most powerful mode in the RISC-V system. But NuttX for aux64 won't work in RISC-V machine mode. It expects to run in RISC-V supervisor mode, which is one level less powerful than machine mode. Why supervisor mode? That is because RISC-V SBCs, like aux64, will boot OpenSBI in machine mode. This is the supervisor binary interface. It is like BIOS for RISC-V. OpenSBI then boots the NuttX kernel in supervisor mode. Okay, technically OpenSBI boots the U-boot bootloader followed by NuttX kernel. This means we need to tweak TinyEMU to boot NuttX in supervisor mode instead of machine mode. And we don't have OpenSBI in TinyEMU, so our BIOS for RISC-V is kind of absent. Hence, we emulate OpenSBI in TinyEMU, just the bare minimum of OpenSBI that is needed by NuttX, like for handling system timers. Remember the TinyEMU boot code we saw earlier? It boots our NuttX kernel in machine mode. Now we modify the TinyEMU boot code so it boots NuttX in supervisor mode. First, we delegate all exceptions and interrupts so they get forwarded to NuttX in RISC-V supervisor mode instead of machine mode. Otherwise, exceptions and interrupts will whoosh by and bypass NuttX altogether. We are about to jump to NuttX kernel in supervisor mode. The way we do this is rather roundabout. First, we set the previous privilege level to supervisor mode, and we can execute an mret return from machine mode that will jump to the previous privilege, which is supervisor mode. We solve our headache. TinyEMU boot code now boots the NuttX kernel in supervisor mode. What about the RISC-V system timer? How do we emulate OpenSBI so that system timers will run correctly on NuttX? RISC-V system timer can only be set in RISC-V machine mode. NuttX runs in RISC-V supervisor mode. That is why NuttX expects to call open SBI to start the system timer through an eCall system call that will jump to machine mode. To emulate open SBI, our modified TinyEMU will intercept the eCall made by NuttX and set the system timer for RISC-V machine mode. NuttX expects to read the system time through the time CSR register, like this code from NuttX kernel. CSR means control and status register, controls a RISC-V system. We have a problem. The time CSR register doesn't exist in TinyEMU. Thus, we emulate the register in TinyEMU. At startup, we search for all RD time instructions. We patch RD time to become an eCall system call, and TinyEMU will emulate the eCall to return the system time. We have a few more steps to emulate the system timer. I won't cover the details today. Please check out these links. We talked about emulating the time CSR register because TinyEMU doesn't support it. Is there anything else that TinyEMU can't handle? Yep, inside the BL808 SoC is the T-C906 CPU. NuttX for AUX64 will call these special RISC-V instructions to flush the MMU cache for the C906 RISC-V CPU, dcache.io and sync.s, which come from the C906 extensions and won't work in TinyEMU. Thus, we patch these special RISC-V instructions to become eCall system calls, so they won't crash the TinyEMU emulator, though we don't emulate the instructions right now. We talk about these special RISC-V instructions in my presentation on AUX64 SBC. Please check it out at this link. Our AUX64 emulator works great for emulating the UART controller and GPIO controller inside AUX64 SBC. Here, we run the QuickJS JavaScript engine on AUX64, which will blink a simulated LED connected to our emulated GPIO controller. We have a presentation that explains how we ported JavaScript to NuttX. Please check out the link below. We wrap up today's presentation with a super helpful way of using our AUX64 emulator. That is for daily automated testing of NuttX on AUX64. Let us walk through the implementation of the automated testing based on expect scripting and TCL. Yes, the good old scripting language. This gets triggered every day by GitHub Actions and alerts us via email if the daily test fails, which is terrific for NuttX regression testing. What exactly is an expect script? With an expect script, we can feed our commands automatically into the emulator. Here is an expect script that sends the uname command to our AUX64 emulator. If the NHH prompt is missing, or if the uname command takes too long to execute, this expect script will fail. Our expect script runs automatically like this. Will it work for complicated tests? Yep, that is the beauty of TCL scripting. We may use pattern matching and timeout detection in our script. It works really well with OS tests for testing everything in NuttX. And this is exactly what we do every day at GitHub Actions. Run OS tests on AUX64 emulator and fire us an email if OS test fails on AUX64 emulator. How thorough is OS test for testing everything in NuttX? Super thorough. Last we checked, these are the NuttX tests executed by OS tests. Today, OS test has probably added a few more NuttX tests. Running daily automated tests on AUX64 emulator is probably the next best thing to running daily tests on a real AUX64 SBC, which we might try next. One final word on emulators. Recently, I'm so hooked on running good old games, Pac-Man, Collection, Street Fighter, on a retro gaming emulator like RetroArch, which got me thinking. RetroArch will actually emulate a couple of interesting architectures like ARM32, Z80, X64. What if we could run NuttX on RetroArch? Then we will have NuttX on RetroArch on iPhone, iPad, and Apple TV. As we ported NuttX to TinyEMU and created the AUX64 emulator, we wrote plenty of detailed notes. Check out the articles here. We have 2 more presentations on AUX64 SBC about porting NuttX to AUX64 SBC and the analysis of real-time logs from AUX64. Please check out the presentations at this link. The great news, our NuttX website now runs NuttX. Anyone in the world can click into our website and try out NuttX for themselves. We created an emulator for AUX64 SBC that is super helpful for automated daily testing and regression testing. Maybe we can create more emulators for NuttX devices and make NuttX development a little easier. Thank you.
Thank you, Luke, for such a great presentation.
Yep, so I'll begin the Q&A. So Tomek, you posted 2 questions. I'll talk about them now. So the first question you posted, is this virtual I/O a kernel or user land mechanism? Does it require kernel level support, or is it just a library that enables communication between host and guest in virtualization? So good question. Virtual I/O is more of a it's a virtualization protocol. So it's used between your guest and the host. Today, I see two ways that virtual I/O is used. Virtual I/O is used in memory map I/O. So a guest can talk to the host through memory map I/O to send virtual I/O commands. The second way is to use a emulated PCI interface, right? So these are 2 ways that we're using. And in fact, TinyEMU today, we use memory map I/O because it's simpler. So there is a library that sits between kernel and user land. I mean, the host and the guest of virtualization, and that is OpenAMP, the Open Asymmetric Multiprocessing Library. So OpenAMP library implements message queues. These message queues are used by virtual I/O in memory map I/O mode, so that they can send messages from from the guest to the host and back. Right. So hope that clears up. Virtual I/O is more of the protocol, how you use the memory map I/O and how you use the PCI emulator interface to talk to the host. The library is actually OpenAMP. So NuttX uses OpenAMP library to implement the message queue libraries, which will talk between the guest and host. Okay. Second question, so Tomek says, yes, he wishes more companies supported open source research like this. I fully agree. So I heard Marco's earlier presentation on Renode. That's excellent. Just that some of the newer SoC makers are not on board, and maybe I see most of the bigger companies on Renode. The smaller ones are missing. So specifically, I'm talking about more of the newer RISC platforms like BL808. They're missing altogether from Renode, right? Maybe because they're too small and they don't have the resources to do it. So my work today proves that it's actually not that difficult to build your own RISC-V emulator, right? So I'm really hoping RISC-V SoC makers, please consider building a emulator like TinyEMU, right? You can easily customize it. release it to your customers, so we can easily port things in NuttX. And also, as you can see, we're doing daily automated testing on NuttX thanks to the aux64 emulator. So it's really useful for SoC makers to consider investing in these emulator tools for their SoCs. And one last thing is that today I'm porting NuttX to another RISC-V SoC, the Softgo SG2000. I'm going to do the same thing. I'm going to port TinyEMU to SG2000 SoC, so we can do this easier porting and also easier daily automated testing. Yeah. Yeah. So any other questions?
Thank you, Luke, for the presentation. Do we have questions in the room?
I have one question.
We have one question in the room.
Can we run TinyEMU on NuttX?
Can we run TinyEMU on Linux?
On NuttX.
Oh, NuttX. Okay. Good question. Potentially, TinyEMU is just a plain C application, so it's actually quite easy to compile. It works on GitHub Actions, it works on Ubuntu, it works on macOS. So I believe it might be possible to run it on NuttX. But then the emulation speed might be a bit slow. So I'm just wondering. Yep, potentially, technically, yes. But I'm just curious how we want to run it on NuttX.
Thank you, Luke. Do we have more questions from the room? It looked like there are no other questions. Thank you very much, Luke, for the presentation and the Q&A session.
Thank you.
The next presenter was supposed to be talking about the Sony's Presence IMU board, and he is currently stuck in a meeting, so Koizumi-san will take his place. I already updated the main site schedule. So let's welcome Koizumi-san, which will talk about the audio signal flow framework on Presence with NuttX.
Okay, thank you. Okay, hi.
We are in the back channel. We are in the back channel.
Oh, okay.
Thomas, can we start? Thomas?
Yes, we're live now.
Okay. Hello, everyone. This is Takashi Koizumi, and I will present audio signal flow framework on Presence with NuttX. But just before my presentation, let me introduce just the surface of the Rev 2, the lunar journey of the NuttX. So, you know, the NuttX operated on the moon without any problems. That's a great thing. Yeah, the NuttX, great NuttX. And Rev2 is uses expressions actually, and it runs on the moon or performing the image recognition on expressions and successfully transmitted JPEG photo to Earth. And this means NuttX works on the moon without any problem. And actually, the NuttX version is used at this time. It was 7.22. Yeah, a bit old, but you know the space things is takes a long time, so it's a usual thing, I think. And about the Rev1 and Rev2, so the three spacecraft carried Rev1 and Rev2 and split them on the moon. And these Rev1 and Rev2 is a robot standalone working on the Earth, on the moon. And Rev1 is moving, just hopping, jumping on the moon. And faced on their net the antenna to the Earth, and Rev2 is split sphere as a tire, a kind of tire, and look at the searching the Rev1 by the camera and the image recognition, and if Rev2 find Rev1 and then turn around in the center of the Rev1. Yeah, and this is an actual picture taken by Rev2. So that means different is worked of the NuttX video framework, actually. And by the way, the expressions used in space actually predated Rev2, which was used for satellite orbital mission in 2018. It was a satellite on around the Earth. And this picture is the actual picture taken by the expressions on satellite. So right now the expressions is utilized in space with NuttX is utilized in space with expressions. So yeah. Anyway, the NuttX is very endurance for using the tough situation like in space. So that's great things. Thank you for providing the great OS operating system. Anyway. Okay, so go back to my presentation, and today's agenda is like this. What we want to do for this framework, and I will introduce the structure of the audio framework and application code using this framework, and contribution plan. Okay, so what we want is there are four purposes I have, and one is make each audio signal processing block independent and reconfigurable at runtime, and create a program model that is intuitive and easy to understand in the application code, and easily add new signal processing component by a user, actually by a application programmer, and make effective use of the expressions 6 cores. So, for example, there is a kind of the requirement like apply FFT from audio input to AI for sound recognition, and at the same time store audio input data to the SD card or send it to the network. So when AI recognizes something, many people complain that they want to know the validity of the recognition result. In addition, the original data is indispensable to make AI rerun. For this result, such cases are very common, I think. So that example, the block diagram is like this. Of course, it's very simple. The audio data is initiated on audio input, like a microphone. And after that, the data is going to the FFT and the AI. And in parallel, it will be the file saved to the file or sent to the network. So build a framework that allows for institutive programming of such structures. That is the purpose. And this is a basic design of the structure of the framework. The basic unit is a block called component. That processing the voice data, actually sound data signals, and components are connected to each other to achieve the desired functionality. Each component has an input node and an output node, and this input and the output can be connected, actually bind to each other. The output can be connected to the multiple inputs. Components include source component that provide the voice data, and sync component that serves as an endpoint of the voice data, like this. And about the data flow, so audio memory is acquired via a dedicated allocator. The memory has a reference counter, and when the reference counter reaches 0, the memory is reached to the allocator. It's a simple, usual reference counter things. And the source get the memory from the allocator, create and capture the data, audio data, and then pass it to the radar component. And intermediate component processes the incoming speech data from the input node as needed, and flow the result to the radar component via the output node. The terminal component is received the data and such as play to speaker, and then release the received memory. At this time, if other component are using this memory, of course, the reference counter is not 0, then actually the keep using on the other component. So the structure is like this. And handling the audio data on in component. So when the data arrived at the input node, each component calls its member function on data. And in on data, audio data is acquired by the pop data and processing proprietary, and then pushed to the output node by push data. And if user create a component that perform its own signal processing, it inherited the component and override just on data. And handling the system message. So when the audio play or recording is run, the processing is executed asynchronously. So error or some kind of the status changing notification that occurred during the execution notified to the user asynchronously via the event listener. So, and offload to Space's other CPU. So with this structure, the operation in the audio component independent. So, and it can be offloaded to another core expressions like this structure. So now that is the structure of this framework, and from now I will show you the sample code, how much easy for using this framework. So right now, this code is in Expression's GitHub. Later on, I will explain the contribution plan. So this example is to target to create this structure, get the mic input, and just display the data. It's emulate kind of the signal processing. Just this one is just an example. So just show some print some audio PCM value, and audio output to speaker. So this one is just audio through things. And on the initiator, the source of component, it needs a memory allocator. So the memory pool for other allocation. So this is user original sample like this. And just override on event, then the user can get any notification from the audio framework. And create instances, and audio input and the output, memory pool, and the middle component, which is user original. And set up the parameters. It is just this system is using the 48 kilo sampling rate and 16-bit sample, and 2 channels. And set the event listener on the system. And after that, create a memory instance. So 4K byte and 8 tiles memory pool is created on this code, and set the memory pool on the audio input component, and then bind the components like this. So now audio input, display data, and audio output. So these 3 is binded like this. And just after that, then just start it. Then it can be worked. So this one is implement of the original audio component. So as I explained, just inherit the audio component and override on data method. Then you can focus on implement signal processing, pure signal processing after getting the audio data. So this one is a total source code of the audio signal, the audio through. So without comments on example code, very short, you can see. So I think that is much more instituted code. So that is what we want to do. And now about the contribution to the upstream. So currently, this framework is only available in the Express SDK Express repository. There are two reasons for this. One is currently the NuttX audio driver for the Express is not enough for supporting this framework. We need to update, and now we under contribution and the PL. So after this PL is merged, then we will start to contribute this framework to the NuttX. And secondly, there are some components of the processing to another CPU, and there are dedicated to expressions. Example, for example, MP3 decoder is run on the other CPU. So, this is just specific for the expressions. So for first, we will address the PL 1 point and merge them. And for second, we plan to finish the work by summer and implement the PL including the framework. So yeah, that is a plan. So yeah, this is a summary. We built all this processing framework, and what we want to do is four things I explained, and all done by this framework. And the contribution to upstream will also proceed. That also, thank you for the attention.
Thank you, Do we have any questions from the room? Seems like there are no questions for the audio framework. With this last presentation, we will take a long break, and we will meet again at 1:45 for the second part of the session. As yesterday, we will have lunch with attendees on their own. If you want to tag along, feel free to come with us. We will go downstairs. Thank you very much. Also, thank you, Thomas. You need a break, and we will come back soon. See you at 1:45.
There you go.
So you can open the camera.
So, can you hear me?
You have to
Yep.
introduce yourself.
Oh, hello guys. I'm Alison and I speak in Japan. So, our presentation, our next presentation, it's very nice. A presentation. We have a demonstration, and let me introduce Alan. We are make our next presentation. So, please go ahead, Alan. Introduce yourself.
Thank you, guys. My name is Alan, and probably some of you already know me. And so, my idea today is present about a project that I developed using NuttX, and it to be useful for me and many other people that like, for example, motorcycle or bike or anything else that needs some head-up display to show information or show the map while you are driving or riding. Alan, are you still here? No. Actually, he left. I need to download again my presentation. Just a second, Thomas. And here we go. I don't know. I'm lost here in the middle of many tabs. He has more tabs than my. So I don't know. Where's the last one? Probably the last closed, reopen, closed. No.
How can I help?
I need Alan actually. Alan, can you please? Yeah, this one. I need to download my presentation.
No, it's already open.
It is outdated.
Okay.
I just updated it.
That is the one that you sent.
I'll just update that. Okay, just a second, Thomas. I'm downloading the last version. Here we go. Okay, can I start? Okay.
Thomas knows.
Okay, Thomas, is everything all right? Let's do it here. Start presentation. Start presentation. Okay.
No
Yes.
screen yet?
Yes, let me share it. This one. This one. Share screen.
There are two.
Yes, because somebody opened.
Yeah.
But is this the last one?
It's the last one. Yeah. Okay. It's coming.
Yep.
Yep. It's already there.
Yes, but I'm not sure if you can.
Can you see?
Yes, the screen is visible. All fine.
Yes, visible. Okay. It's in YouTube already. Okay. Can you confirm it's okay?
Yeah, I just confirmed.
Okay.
Move one slide back.
No, let's move.
Yeah.
And go back.
Okay.
Yep. Okay. Great. Hello, everybody. I am glad to be here, and this is our 6th International NuttX Workshop. And today, I will present about a project that I developed for myself, but it's also very useful for everybody that want to ride some motorbike or any device that you requires a helmet. For example, Formula One cars and anyone. Maybe
Whoops, I lost you guys. Hello?
Yeah, I think it's some issue on there.
Can you hear me? Alan? Anyone from Japan?
Crash.
Yeah. Online.
Yeah. These online things happen. So, my name is Alan. That's the second time I present it because the first time it crashed, the computer restarted. But let's see if we can do it now. Kangaroo, how to say the Kambari, very hard here. So I will present about my project where I create a head-up display for motorcycles or motorbike helmet using NuttX. And so this project is not for only motorcycle, so we can use it for any vehicle or any export that requires helmet, even for astronaut from NASA or SpaceX, it could be useful. So if someone from there are listeners, let's to implement this idea someday. So let's move on. First, what is the head-up display and the history about it? So I will present the history and how it was developed over the years, why to create a head-up display for motorbikes, how I came up with this idea, an overview about the architecture of this project, how things are interconnected, implementation and issues and challenges that I faced during the development, and the testing and demo here. So, and also the improvement for future versions. Okay, from Wikipedia, what is the head-up display? Basically, a head-up display is any transparent display that presents some data without requiring users to look away from their usual viewpoint. So, as you can see here in the screen, this is what normally some airplanes, aircraft, and some helmet of the fight jetters use to get information without looking to other place. Because, for example, imagine you are in the fight in a fight jet, and you need to look down to get some information. So this is enough time to get some hit or crash with other aircraft. The first head-up display patent is from 1937, so it's almost 100 years already. So it's already old technology, let's put this way, but it's still new. And for this original idea, as you can see here in this diagram, it was like a teleprompter. You know, in TV, the teleprompter idea, you have some semi-transparent mirror, and it reflects back the image from the back, and you can see the image in front of you with this information overload or overwrite over that. So a history about the overhead display continuing, for example, during the following years. Initially, that application was more used for like some guns main target point. So you see exactly where you're going to shoot. So the initial purpose of the technology was not for only get information about the speed or something like that, as we have today. It evolved around the years. So initially in the Royal Air Force in the England, after that Royal Navy, and it evolved a lot after the 75 with this Klopstein company. They became very famous manufacturer of head-up display for aircraft and commercial airplane. And currently, most commercial passenger aircrafts use head-up display. So why to create a head-up display for motorcycles or motorbikes? First, because it's improved security. For example, imagine you put your smartphone in the motorcycle dashboard. Every time you need to look back, you are remove your focus from the street. So it's not ideal. And using the head-up display, you can improve this issue. You can avoid looking down and just focus in the street. Also because it is convenient and easy to use. So, for example, you don't need to have to stress your head looking up and down all the time, your neck. And also the most important, because it's a really fun project. So I enjoy doing this project. And to be honest, I think it was one of the most funny project that I have developed over the years. And how I get this idea, how I realized it could be nice to create some head-up display. Some years ago, I was using the Google Maps, and when I hit the home button, I realized it's create a picture-in-picture image. This white square in the here in the screen. And then I realized, oh, if I have some small OLED display, transparent OLED display, I could draw this image on that display. But at the time, I didn't find any transparent OLED display. And some two or three years ago, I saw they release low-cost OLED display that is very easy to find on AliExpress and many other robust sites. As you can see here, it's running on NuttX, and it is completely transparent, not completely, but 80 or more % transparent, so you can see the background and still seeing the image drawn on that. This is my idea of the architecture for the project. In the left side, we have your smartphone. That Google Map picture-in-picture is in the corner, in the top left side, and it is running the VNC server. Why to use VNC server instead of create an Android application? First, because I don't need to create the application myself. is a good advantage. The other advantage is, imagine if I create it for Android, and for some reason I decide, oh, Android is not good anymore, I want to use iPhone. I hope it never will happen in real life, but let's suppose it happens. So I need to recreate the same application to iOS as well. So it's not good. And using VNC server, I can do it for any device, any smartphone that has VNC server, or even computer or anything else. So VNC server simplify the project. And in the right side, we have NuttX board. Actually, it can run in any NuttX supported board. We can use it with Wi-Fi, Ethernet, USB RNDs to connect with the board. In my project here, I am using USB RNDs, and it works well. Although I think using Ethernet or Wi-Fi, it will be faster because this board is only USB full speed. It's not USB 2.0, not high speed. So the NuttX application will communicate with the VNC server. So I create a VNC client, and it will request this picture-in-picture area, and it converts the image and it draw it into display. So before implementing the application, I decided to do some tests using VNC client and use the GIMP to do the edge detection algorithm. So as you can see here, the original image is a color image, and then I use the Sobel edge detection. Sobel is very used for image recognition algorithm because it is simple to implement and it is fast compared to other more advanced algorithm. And then after the Sobel image was created, I converted to black and white. But there's some catch, there's some issues here. For example, if you do the Sobel conversion directly to black and white, you will miss some information. Some lines, for example, will disappear, or things bad will happen. So first, I sharpen. I increase the visibility of the line, so the colors become more sharp and more visible, and then I convert it to black and white. As you can see, all the information now are present in the final black and white image. And why black and white? Because that OLED display that I was using is only one color. It's only like green or blue in that case. So this way, I can only send one bit pixel. I can only have it on or off. My first attempt was use some existing VNC client, and I found this VNC view. It's a VNC client for Windows CE, and it is available in GitHub. But after I get it working, I ported from Windows CE to NuttX. And it was very easy to port because it was implemented in C, and because all the socket APIs are POSIX, so it's easy to convert. The only function that I didn't know is a Win32 function, and I used the ChatGPT to convert it for me and ask it how to do that, and it helped me. But after I get it working, I realized it was not a good idea because the code quality of this, I hope this guy Wolfgang is not listening this presentation, but his code quality is like my code quality when I was in the high school. So, yeah.
Then let's help him.
Yeah, maybe we can help him. But I found a better alternative. I create one from scratch. Oh. And what I did, basically, I got the VNC server that exists on NuttX and just did the opposite. For example, if the server receives some message, I know what the message I need to receive. So my VNC client just sent that kind of message. So it was mostly simple thing to do. It was, I don't say it's very, very easy, but it was easy to do. And the things was wrong was mostly my mistakes. And I will show about it just now. The first issue, as you can see here, in the first frame, I got all the information correctly, the X, Y, W, and H information correctly. But in the second frame, it starts to drift. As you can see, all the information are completely strange. For example, the position is an invalid value that doesn't exist in the display, for example. And I just realized that after request the frame and get the rectangle area, I was passing the area, the amount of the bytes I want to read, and also the size of the structure. But since I received the first data of the structure, I don't need to pass the structure size again. So I just remove that part that is not required. And here I have the weight and width and weight size multiplied by 4, because the Android image is 32 bits. So it's green, yellow, green, blue, and red, and transparent, the alpha. Yeah, exactly. And so I multiply by 4 because we have 4 bytes for each pixel. The second issue was because first I implemented this VNC viewer on Linux. I got the VNC server from NuttX, compiled it on Linux, and it compiled out of the box. I didn't did many modifications on that. It was mostly work directly on Linux. And then I start to create the VNC viewer, implementing the things that were supposed to be implemented. But I didn't pay attention about the memory, because when you are in the Linux, you have all the machine memory. So who cares about the memory now? But after converting it, after compiling it on NuttX, I realized the CNC buffer was already big, because I was reading 128 by 128 by 4. And I was converting it for RGB 888A to RGB 888. So I was converting for 4 bytes to 3 bytes for each pixel. And this other buffer for receive these 3 bytes to remove the alpha, the transparent color, was already 49 kilobytes. And also I need another 49 kilobytes to save the edge detection image. So at the end, I was using too much memory because I was doing many conversions, and each conversion required more memory. So the first idea was just use the same RGB alpha buffer to convert it to RGB. So I just need to move the red to the alpha position, and then the green to the position was red was before, and then the blue to the green, and so on. And this way, I don't need to use more 44 kilobytes of buffer. And my next idea was also to convert the Sobel pixel to use only 4 colors, because as you saw in the previous image, it was only using four colors actually. So I don't need to have 32 bits to save all the colors. But I don't need that, because after I removed the RGB buffer, it was already enough to compile on the STM32F4 Discover board. So I decided to not to do the next optimization. So as you know, too early optimization is the root of all evil. So let's keep this way for now. And this is what I see inside the helmet. As you can see, there is it's not so easy to see here in the screen, but it has the arrow that's shown in the Google Maps, and you can see the street. And also it's running here, and we have also some recorded video.
I can show the demo from here because I have access meeting. So
okay, if you want to play it, maybe Thomas
I can open my camera, I can show.
Okay, good idea. Thomas, can you show Alison camera?
Yes, sure.
I don't need microphone. Yeah, one more slide.
No, I just turned on the microphone.
Okay. Keep it. As Alison is showing here, we have the image in the Google, in the Android phone, and also display in the transparent OLED display, as you can see. It's only about 1 or 2 frames per second, but it's enough for using the helmet. And my idea is also to port it, for example, to ESP32 board. This way I can use Wi-Fi, and also I have faster processor, and it will be enough to get more frames per second. Okay, thank you, Alison. And now I need to return to my presentation. Okay, it's already okay, Tomek. Did you open the mic? Okay. So some future improvements. For example, my next idea is to use a bigger resolution transparent OLED display. For example, 128 by 128. I forgot to comment. This small device, this small display, is only 128 by 64 pixels. So I only see the like the middle of the picture-in-picture image. I cannot display the entire image, but even the middle is enough to get the idea about the map. So, for example, now we can see some flexible OLED display coming into the market. So, use some flexible, some plastic OLED display is better than using glass display, and it can shape or can adapt easily to the helmet visor, and it is better to use. So although initially I avoid create the Android or iOS application, but I think it could be easier because I don't need to do all these edge detection algorithm and so on in the board. I can do everything in the Android phone and just send the converted data. And that's it. So I hope you guys have enjoyed this project. And now we can, if you guys can come here and see it directly in the running in the board. And that's it. Thank you, Tomek.
Thank you, Alan. A really nice implementation of NuttX in a community project for a heads-up display. I bet that this kind of ideas have been used in the past and they will be used in the future by many companies.
Yeah.
I can see a really nice usability for skiing, because when you ski, you would want to see where you go.
Mm-hmm.
And especially if you're off-piste skiing, so there are no flags, no nothing.
Yeah.
So good luck with your idea, and hopefully we will see it in a product in the market.
Yeah, I hope so. And the other idea is to contribute the VNC viewer to mainline, because for example, currently we have only VNC server, and sometimes you are running in a board that has a good display and want to show some image from a computer. And also, the idea is to implement it like a VNC camera. So if you want to do some image recognition and you don't have some camera, you can just export the image as a camera. So your application will open like /dev/VNC can 0, and we'll get the camera that have some pixels coming from a computer or from remote real camera, for example. Yeah, that's it.
Thank you. Do we have questions in the room or online?
I would have one question or several questions. Very nice project. Congratulations, Alan. I was, working on thinking about something like this several years back, but there were no translucent displays yet. I saw one prototype in 2017. There was some company from Japan. The display is working, but the guy didn't even yet know, how much would it cost and what would be the availability. But then, I asked Google to create this kind of layer in their application, and they added to the this Google Maps navigation special function for head-up display. So maybe aside of the VNC, it would be possible to access some special API in the Android just to get, the special display for the head-up display. So it's already there in Google Maps navigation. That would maybe make things easier, faster, So what display did you use, and how much does it cost?
This is SSD 1309. As I told, it's very low cost. So it costs, I think, 10 or 15 US dollars. So it's not expensive. And that's the main advantage of this solution, because it's really low cost. And for example, you can create some product with that, and it will cost few US dollars, probably less than 100 US dollars for sure. And yeah, this OLED display is used by many Arduino makers, so it's very accessible, very easy to find in any hobbyist or online shopping.
Very cool. Yeah. Another problem I noticed, it would be kind of when it's gonna be a product, then you need to fit it with the MCU board and then mount it in a helmet in some standardized way. For example, my helmet, I use pin lock on the front shield, so I cannot really attach it to the shield, and then there is a problem how to mount it, so it's safe in case of crash and so on to match other helmets.
Yeah, the ideal, the best solution for that, the ideal solution, is mounting this thing directly in the visor, in the like in the side of the helmet where it's turned and like there is the spinning spin nudge that you can move up and down. So that area could be used for that. And so, for example, you can keep some USB charger on that, and before you go, you put your helmet to charge a little bit to charge the battery, and it will last for 1 or 2 days, for example.
Yeah, or you could put some, energy harvesting like wind or something outside the helmet and just, charge it with the speed of riding.
Yeah.
Congratulations.
That's also a good idea.
We have a display which will use some energy, so I don't think that it will work on harvested energy. Anyway, I found on Google there are some interesting waveguides displays.
Yeah.
A bit more expensive, but maybe worth it.
Actually, I forgot to comment and to include here. There's a nice YouTube video about it. It's called 1 billion, one US dollar billion idea, and the guy talk about not about only about the read-up display, but all the technology existing today for display image in front of your face, because because the Apple Vision Pro, many companies now are also interested on that, and that kind of technology exists for a very, very long time, but only after some big companies start to make a dent on that, all the other small fish go after this whale. So that's the conclusion why there's so many people interested in that. And I try to find it. Maybe we can I can find it in my cell phone, please, and I'll share it here. So
maybe an idea would be to share it on Discord.
Yeah,
And continue with the
conference. I can share it with Tomer later if he's interested. And I think that's it. Okay. Thank you.
Thank you very much.
Thank you. And if you guys want to come here, turn off.
Yep.
Forget it.
Please. The green board, the one where the camera is sitting. The green board. Yes.
live.
10 minutes.
Right now.
Okay. Hello.
Please introduce yourself.
Sorry, why my screen?
I don't know. That's not something that I.
Hello, I'm Kosei Yamashita, Sony Corporation. Today, I introduce our new add-on board, development of a compact high-precision IM board for presence using March IM synthesis technology. I'm afraid this is a kind of out of scope of NuttX, but this is just a new add-on board application topic. I'm happy you have interest in this new add-on board. This is the overview. Here is our new prototyping board, multiple IM board cross process. This board has two benefits: low bias instability and low noise density. And what is the IMU? This board has a 6-axis inertial measurement unit, IMU, and this board consists of 3-axis accelerometer and 3-axis gyroscope. What are the features of IMU? IMU is very unique sensor. Inertial sensors can be used anywhere in the world, such as underwater, deep underground, in the sky, and space. Inertial forces act equally everywhere, so independent of the environment. So this is IMU benefit. Yes. And what is the IMU used for? Application. Maybe you have many IM applications such as game controller and motion capture and AR, VR glass and image stabilization, drone and navigation system and robot. So now IMU are very popular sensors, and every year new IMU products we can get new IM products. And one more important function, data reckoning. Data reckoning is it can be useful in a place where camera and the GPS are not available. IMU connect between movement tracking environments such as GPS can't work environment and SLAM doesn't work environment, but IMU can connect between movement tracking. Yeah. And what should IMU has open issue, technical open issue. Most big technical issue is drift error. IMU sensing has drift error, such as position tracking error and posture attitude tracking error. And especially position tracking error is increasing by time exponentially. So this is a big problem for IMU technology. So we can get two types of IMU in this market. One is a high precision IMU. This is an industrial grade IMU. This type is optical gyroscope, very heavyweight and very expensive, millions of yen, but very high accurate, very low noise. And on the other hand, we can get a MEMS type IMU. That's very small, installed in smartphone, and very lightweight and very reasonable, but very big noise. This is a big two types of IMU. So with Sony aimed for a new type of IMU. This IMU has a very
high accurate but small size. This is a VIME new type of IMU. So our technology is focused on, we take a new approach to get a high accurate IMU. That is a multi-IMU system technology. This multi-IMU system technology has two benefits. One is low bias instability and low noise. Here, single IMU has a big noise, but multi-IMU has a very small noise. And the second benefit is the redundant reliability. This IMU has multiple, so we can reject the IMU error real time. That is the redundant reliability benefits. And this is our second prototyping, 32 MEMS IMUs on board and real-time processing by FPGA. And this research was collaborated with JAXA. JAXA is the Japanese Aerospace Agency. And we can get 0.5 degree parity bias instability. This is accuracy is comparable to the industrial fiber optical gyroscope. And this is the third our prototype, more small type, wide size IMU, and very small type. But this IMU has very high accurate comparable to fiber optical gyroscope. Using this IMU, we challenge the space mission. This Sony's SPR box is a mission box, and this box has our 32 IMU combined multiple IMU and this presence. And we tried to estimate the satellite attitude by this IMU, and we could successfully estimate the attitude in the space. And also, we keep conduct this mission through 1.5 year without no error, because this IMU has redundant reliability. So here's our IMU board features, very high precision and high robustness. This is our 50 millimeter size and 10 gram weight, very low weight. And this is a noise level graph. Here's a single level noise level, and this is multiple IMU noise level is blue line. It's multiple noise level. And please check the Earth rotation rate is 50 degree per hour, and our IMU noise level is 0.39 degrees per hour. So our IMU board can detect the Earth rotation rate easily. So this is just image of Earth rotation rate. So this is just a prototypic IMU. So this IMU can sense the Earth rotation real time, and this IMU can find the north direction. This is the gyro compass technology without no magnetic. We can find the north without a magnetic sensor. Yeah, this is the gyro compass technology. And this board is a very simple configuration connected to presence by SPI, and getting power from presence board. So you can plug it into the presence board, and it's ready to go. Very easy to use this board. And this is specifications, detail, very high dynamic range and very low noise. Gyro sensors is very low noise, and the acceleration sensor is also low noise. Yeah. And this is just a model of IMU fusion function. Sony's March IMU board is just like a one IMU. So the Sony's process board has many functions, GNSS and camera and the communication device. So if you can get this board, you can make many good application with GNSS fusion and with camera fusion easily. This is our benefit of process family. And okay, on the last, we demonstrate inertial navigation system. IMU has a function of inertial navigation system. Inertial navigation system is tracking the car tracking and human tracking, and this is just technology only IMU only tracking, and this is our simple demonstration board. Sense board and IMU board and very simple rover, just a hobby class rover. And this is a demonstration video. This rover tracks the same course over 12 minutes without no drift error. This rover works, moves only IMU, no camera, no odometry. Yes, so this is very low drift technology demonstration. And one more, this is a sweep, tire sweep demonstration. This rover doesn't use tire odometry, so this rover can track their goal. Because this IMU only sensing the accelerometer and the gyro sensor, so this tire is sweeps, but well, this rover can keep the tracking. Yeah, this is a new function. Okay. And this board has a very big potential for new application in the navigation and drone bridge inspection and motion capture and satellite altitude control. So we have many potential for new application. Okay, this is my summary. This is just a prototype. We are developing a new multiple IMU board for process, and this board is applied for new applications such as vehicle and rover and autonomous vehicle and drone. Yeah, and we demonstrated this board next door, but it was already finished. Sorry. Yeah. Please. Okay. Thank you for your time.
Thank you very much for the presentation. It's nice to see that the NuttX community gets access to new technologies that hopefully will be open sourced, or at least the driver will be.
Yeah.
And my question is if we will be able to get access to the driver and have support for the IMU in NuttX mainline. Are there any plans for that?
Yeah. How can I answer it? NuttX. Yeah. We provide. This is just IMU board, and we also release driver software and the library software to you, and this maybe NuttX library. I'm sorry, I'm not sure. Yeah, but we can support this board and the software on NuttX.
Super. Looking forward to have support for it and maybe implement it in the helmet from Alan or other cool projects, maybe a drone.
Yeah.
Do we have other questions from the room? We have quite many questions from the room, please.
Thank you for the presentation. Yes, very surprised.
Yeah.
I have a lot of many questions.
Yeah.
I don't know the maps I am have a lot of many errors.
Yeah.
So you are using the multiple IM, you can reduce the error, right?
Yeah.
So the question is if by using multiple IMUs, you can reduce the error.
Yeah, right.
We have to speak for the microphone. I have to repeat the question.
Yes.
But I thought you, I thought you used the filter. So which kind of filter do you use?
Okay.
Any filter?
Yeah, a kind of confidential, but yeah, very simple synthesis algorithm. And you mean the error is a drift error or any other error? You mean, yeah.
For the methods, there are many errors because
Yeah.
from the for the data reckoning, we have some errors.
Yeah. Firstly, we calibrate each IMUs and we combine each IMUs by our special algorithms. And this brought very low error and low drift. And also we applied our software technology reducing drift error for signal processing. Yeah.
You mean you use some filter, like Kalman filter?
Yeah, a kind of common fit. Yeah.
When do you expect to sell this board?
In this after this autumn, this fall, this year, the end of this year. Yeah.
Hopefully.
Hopefully.
Paper will publish them different.
Paper. Yeah, we press released and please check Google Sony multiple IMU. You can get more information on the internet. Yeah.
Do we have other questions, please?
The IMU is just a commercial one. It's not a special IMU. Can you share the part number?
Yeah, your question means this IMU.
Yeah.
That's just commercial IMU, and very low priced IMU such as smartphone inside IMU. Yeah.
Can you share the part number?
Okay. Not confidential, but ST Micro's IMU. Yeah. Okay.
Does it include magnetometer also?
No magnetometer.
Only accelerometer.
Yes, that's true.
Thank you.
Yeah.
Do we have other questions?
City has some questions. Actually, I have one question. This solution of using multiple IMU is not something new. I saw something in the past as well.
Yeah.
But what was the innovation you bring to that? Because there are many algorithms that can be used for that.
Yeah.
Did you create something new or something that can improve even more what exists in the field, or it's basically what you have in some papers, some articles already?
Multi-IMU synthesis is very simple but very difficult because this is just a simple graph. IMU, two gyroscope interference each other. Gyroscope oscillates around 20 kilohertz, and one gyroscope oscillates, and one gyroscope oscillates, and crosstalk each other and make a beat noise. So very difficult to implement the synthesis. So we implemented a special signal processing to reducing bit noise. This is our special technology. And this is our paper, IEEE Inertia 2020. Yeah, please check here. Yeah.
And for example, normally this technology, when you read sequentially, we are not getting the same data. Even few microseconds, you already place some data. These in the middle, these FPGA or these chip you are using, it do it like in parallel, right?
Yeah.
Almost in real time.
Yes.
Reading all the accelerometers.
Yeah.
Not sequential.
Yeah. Each IME are not synchronized each other. So this FPGA are parallel requiring data and synchronizing timing and very complex implementation.
It read all IMU the same point.
Yes. And resampling, synchronization.
Unfortunately, not open.
Not yet, but let's hope.
Someday.
You heard in September we get the part number and then maybe we get the driver.
But I think even the library, if someone want to use this board, this technology, it's cool.
You said that is API connected.
Yes.
So it should be compatible with everything.
Very simple.
Cool. Thank you very much for presenting this really cool piece of hardware, and hopefully we get some to play with.
Hopefully, we expect.
Thank you.
Thank you.
Hello everybody, I'm Saurav Pal and I'm going to speak about NEMO FS today, which is a file system that I've been developing as part of Google Summer of Code 2024 for Apache NuttX. And NEMO FS is a file system that is being built specifically for NAND flashes. So what is NAND flash? It is basically a type of programmable non-volatile flash memory made out of NAND gates. So it's non-volatile, which means that the stored data remains there even after the power runs out. So why should we use NAND flash? It's because NAND flashes are very compact, they use lesser wires and thus lesser silicon, and thus have a lesser cost per bit than NOR flashes. They also have a better write and erase times than NOR flash and provide a faster sequential read than NOR flash. So there are some drawbacks of NAND, most notably bad blocks. Bad blocks are blocks that are no longer fit to store data, and these blocks are not guaranteed for consistency of stored data. So NAND flashes have a high number of bad blocks right from manufacture. Also its compact structure makes electrons act up a bit, and some of the bits may get flipped, and thus this requires the need for error correction codes. Also, NAND flash requires more standby energy than NOR flashes. So this is the layout of a NAND flash. So there is a die inside which are planes, and inside planes there are blocks, inside blocks there are pages. The most important part of this is the block and the page. So let's take a closer look. This is the block, and it has two areas that are divided. So one is a spare area which is there to hold metadata about the block. For example, error correction codes or bad block markers, which are basically markers that denote if the block is a bad block or not, and this is set by the manufacturer. And inside the data area there are pages. So most interestingly, the smallest readable or writable unit of a NAND flash is the page, while the smallest erasable unit of a NAND flash is the block. So why should we use a file system for NAND? We want to use the storage device in a painless way, and thus we need a file system to manage storing data for us behind the scenes. So why not existing file systems? NAND flashes put forward a very unique challenge. They require out of place updates, bad block management, wear leveling. Not many file systems have these features supported, and some that do support it require a flash translation layer FTL to work with NAND flashes and to manage the wear and bad blocks for them. So why does NuttX need a file system for NAND flash? Because NAND flashes are very good fit for storing sensor data because it costs less and it has quick writes. Also for tinier boards, this is a very good choice for storage as it's very compact, and this compact nature enables tinier boards and thus a reduction of overall costs as well. So NEMO FS is a copy on write file system that is inspired by LittleFS and a file system which attempts to solve the problems posed by NAND flashes. So this is the directory layout of NEMO FS. We'll come back to this later. Let's take a look at the CTZ operation. Basically, it counts the trailing number of zeros in the binary representation of a number. So in this given number, we have 4 trailing zeros, and thus the CTZ operation gives us 4. Now, let's take a look at what is a CTZ list. So CTZ lists are basically reverse skip lists with each node, say x, having CTZ x plus 1 number of pointers. For example, the node 2 has 2 pointers because CTZ2 plus 1 is 2. The first pointer of the node 2 points to 2 minus 2 to the power 0th block, which is basically block 1. Also, the second pointer of block 2 points to 2 minus 2 to the power 1 block, which is block 0. NEMO FS, as you can see, has CTZ list as the on-flash representation of both the directories and the files in it. The directories contain the directory entries of the files and directories inside them. So the children of that directory, and the file CTZ list contains the file data. So let's take a quick walkthrough of NEMO FS. So any changes to a CTZ list, which is file or directory, is noted down in the LRU. So least recently used cache, and then when this cache is full, it's a node is popped out of it and it's written to the journal, and when the journal is full, it's flushed onto the on flash data. So let's take a look at this in detail. The LRU is an in-memory kernel linked list with each node representing a CTZ list. So it can be a file or a directory. Each node has a list of deltas as well, and these deltas are basically changes requested by the user. This LRU is a trade-off of RAM for wear reduction and is very handy in preventing repeated writes to the on-flash data. The journal is a singly linked list of blocks on the flash. It has n plus 2 number of blocks, where the first n blocks contain the logs of files and directories, while the last two nodes contain logs of the master node. So when the LRU is full, a node which belongs to a CTC list is written onto the flash, and then the new location is noted down in the journal in the form of a log. Because of the file system moving a lot of the time, the first n blocks of the journal move a lot more than the last two blocks of the journal. So the master blocks have lot less number of writes because of the LRU and the hierarchical system. So let's take a look at master node. Master node points to the root of the file system. When the root is updated, the master node is updated. This change of the master node's location is logged into the journal's last two blocks. These two blocks are called the master blocks, and there are two of them because we need backups. So let's move on to the block allocator. The block allocator gives you a page or a block when you need one. If you want a block, it skips pages to the nearest available block, and then it gives you that block. So the block allocator starts during initialization at a random block, and it sequentially allocates free pages or blocks in a cyclic manner. This is inspired from LittleFS, and the block requests are always in bulk because they are used by internal data structures of the file system. And block allocator also has a used pages list and a counter for each block to know how many pages inside each block want to be erased. So we know when to erase a block and when not to erase it. All of the erase operations happen only after the master block is updated, and thus the number of skip pages is very minimal. And this block allocator has a goal of providing a trade-off of RAM for speed. Let's move on to how bad blocks are handled by NEMO FS. Bad blocks are stored as an inaccessible to the user file at the very root. Bad blocks do not occur very frequently, and thus updates to bad blocks are very rare, and so this file will not be updated very much. The bad block results from the file can be cached as well. So LittleFS uses this trick for detection of bad blocks during runtime by reading the contents of a block or a page right after writing to it. So if the contents match with the written content, then it's fine, else it's a bad block and it needs to be noted down in the bad block file. So this is all for my file system NEMO FS. Thank you, and if you have any questions, I'll happy to answer them. Thank you again.
Sir, are you able to take question Q&A?
File system NEMO FS. Thank you.
Yeah, I would like to know any questions that people have.
this presentation from Saurav. It looks like there are no questions. Thank you for the presentation again, and thank you for participating into our workshop.
Thank you for the opportunity.
Hello everyone, I'm Xiaohui from Xiaomi VAA, and my topic is NuttX refactoring M2M decoding and encoding framework. This topic is divided into 4 sections. Part 1, NuttX refactoring. First, introduce the refactoring framework, similar to Linux refactoring. This is the refactoring common layer, similar to NuttX audio half driver. Refactoring core is main attribute, refactoring cap for capture, refactoring M2M for codec. This is device driver layer, similar to NuttX audio lower half driver. This is same camera. This is same decoder. In the refactoring common layer, there are 2 important data structures, refactoring-S and refactoring-OPS. refactoring-S is the main attribute for refactoring, including refactoring-OPS and file OPS. Capture corresponding to G-capture VOPS and G-capture FOPS. And refactoring M2M corresponding to G-codec VOPS and G-codec VOPS. refactoring-OPS is a shared OPS for refactoring M2M and capture, which define the prototypes of all supported OPS. When I treat the refactoring-OPS, it will call the OPS of capture or codec to complete the actual operations. Part 2 introduce the NuttX refactoring M2M. Refactoring M2M overview. NuttX refactoring M2M enters the M2M branch through refactoring core. The refactoring M2M layer implements universal codec code, including codec device registration, buffer management, and so on. Application can easily use hardware encoding and decoding through the NuttX refactoring M2M using a control interface, just like using Linux refactoring M2M. Codec MJS is the generic layer of the NuttX refactoring M2M driver. An instance of codec MJS is created for each registered device node. Codec OPS is equivalent to Linux refactoring control OPS, and each driver needs to implement a corresponding set of OPS. Refactoring OPS flowchart when the application and control comes down. Call the refactoring control, and then call codec OPS through the G-codec VOPS into the M2M and then enter the same decoder. Refactoring M2M data structure. Introduce the defined types and public OPS. Codec MJS is the generic layer of the NuttX refactoring M2M driver, include the refactor-S and codec S. Codec OPS is used to implement the low half codec driver OPS in refactoring M2M. Each codec needs to implement its own OPS. Codec S is used to initialize the codec pirate in codec MJS. During device registration, and to access the OPS through codec S. The codec file S is used to implement a codec instance that includes the buffer allocation and management, also including event manager, have an event pool, and include the FDS for pool FD and the private part for low half driver. The codec tab is used to manage the output and capture queue. It existed in codec file S is here. If we got the last buffer, we should set last buffer flag. The codec event S is a wrapper for V52 event that implement the simple queue management. The application can subscribe the event and the event queued in low half driver. G-codec FPS and G-codec VVPS are defined as count type is the universal OPS of V52 M2M, which initialize the codec during device registration. M2M multiple instance by opening codec device by the codec open. For codec 5, S will be created by codec instance corresponding to by codec 5S. Event handle. Subscribe event for application. Subscribe supported event. Codec queue event for no half driver queue the actual event into event queue. Part 3 Simulator decoder. Simulator decoder. Simulator decoder is a decoder device node implemented by in-work host OpenH264. Codec register allow codec MGS united V42 FOPS and VOPS. Codec open allow codec files call codec OPS open unit of output buffer and capture buffer. GSIM decoder OPS implement codec OPS which wrapped by the GSIM codec decoder. When the simulator is started, codec register allow codec MGS unit the codec V52 VOPS and V52 FOPS. In V52 M2M buffer allocation is handled at the M2M layer. The upper layer requests buffers allocation through request buffers, and the M2M layer allocates the buffer upon receive the request. In a public interface, there are two functions for obtain buffers. The codec output get buffer, the codec capture get buffer, which are used to obtain buffers from the M2M layer. After the buffer is used, the codec output put buffer and then the codec capture put buffer are coded back to return back buffer to the M2M layer. This is same decoder buffer flow. When the output or capture buffer available, a work queue will be scheduled. Codec output get buffer get a source buffer. Codec capture get buffer get a destination buffer. Same decoder process use the source buffer and the destination buffer to do decoding. When the buffer is used, codec output put buffer, return the buffer. Codec capture put buffer, return the destination buffer. If we got a US event, the US event will be queued by codec queue event. GSIM decoder OPS is a collection of OPS for the simulator decoder. Depending on the requirement, the implement APIs as follows. stream on and stream off layer for interface for output and capture. Where output stream on is coded, the host decoder is also set to stream on, completing the configuration of the decoder parameters. Where capture stream on is coded, the buffer queue has already been initialized, and the work queue is scheduled for decoding. Where output stream off is coded, the flash state is set to true, and the work queue is started to flash the remaining buffers. The available interface, where output data available and capture data available. The available interface is triggered, which in turn triggers the work queue decoding process. The JBuffer size interface, capture JBuffer size and the output JBuffer size interface are used to allow the codec to calculate the size of the capture and output buffers, which are implemented by the codec's implementation layer based on its own algorithm. Part 4. NX codec. The NX codec is a command line program used to test and verify the functionality of V2 M2M codec, supporting both decoder and encoder. This is a usage example at the end of the help text for NX codec. Summary. In this topic, I introduced 4 sections. First, introduce the overall framework of V2. Second, introduce the overall framework and the main data structure of V2 M2M. Third, analyze the implementation details of the simulator decoder. First, introduce the NX codec, a command line program used to test and verify the V2 M2M. To wrap up, I want to extend my heartfelt thanks to all of you for being here today.
Hello everyone, this is Chao Zhong from Xiaomi VAA team. Very delighted to have the opportunity to represent our.
Do we have questions? There are no questions.
Hello everyone, this is Chao Zhong from Xiaomi VAA team. Very delighted to. Hello everyone, this is Chao Zhong from Xiaomi VAA team. Very delighted to have the opportunity to represent our connectivity team to introduce you some enhancement we've made to the NuttX network subsystem in the past year. Okay, this is an overview picture of the network enhancement. Let's see the features in the blue words in the right side of this picture. In the driver layer, we have implemented Wi-Fi driver for both QEMU and SIM. In the TCP/IP layer, we have expanded several IPv6 capabilities such as NAT66, DHCPv6 enhancement, and multiple IP address support. We also implement support for the dynamic length ILB and jumbo frames. To make sure IPv6 works fine, we added PMTU-D to detect the shorted MTU size over the path from the source to the destination. For those networks whose IP addresses are assigned manually, we add address conflict detection function to let the network manager know that a normal case happens. We also spend some time to make sure that NuttX and Matter works together seamlessly. Thanks to all contributors' work in our team. They are Zhang Hongyu, Wang Zhe, Wang Chen, Li Qinhui, and Mei Jian. Okay, in my later slide, I will introduce you on the following topics one by one. Here comes to the first topic, Wi-Fi SIM driver. Before this feature was available, when we need to debug Wi-Fi related applications, we have to use a real Wi-Fi board with Wi-Fi functionality built in, which is very inconvenient. With this feature, we can now debug a Wi-Fi application on a PC just like any other regular application debug without a real board. It is very convenient now. This picture in the right shows the SIM Wi-Fi driver's architecture. As we all know that in NuttX, WAPI is used for Wi-Fi operations. And the SIM Wi-Fi driver will translate all WAPI commands into WPA client format request and issue the request to WPA supplicant, who is running in the host side. After receive the request, WPA supplicant will control the Wi-Fi hardware via config 802.w11 or MAC 802.w11 and the Wi-Fi real driver. And after receive the response from the WPA supplicant, SIM Wi-Fi driver will pass the response and format it into the replies to corresponding WAPI request. Please refer to the README file under NuttX Tool SIM Wi-Fi folder on how to use SIM Wi-Fi functionality. Okay, here's a demo on how to use SIM Wi-Fi. First of all, you need a real wireless card, and I already plugged in a USB Wi-Fi dongle into my PC, and its interface name is this, and we need to rename it into W0, and then let's run this script. Tools SIM Wi-Fi rename the old name the W0. Okay, we can see W0 interfaces exist, and then we set the SIM Wi-Fi works under the real network card mode init O1 RNC. Okay, and then let's start the NuttX SIM. Okay, it started up successfully. And we enter if config, and you can see that WLAN 0 exists in the SIM environment. And let's set it to station mode. PI mode WLAN 0 2 and the works in station mode, and let's trigger a scan operation. WAPI scan WLAN 0. After the scan operation is finished, we can see the scan result here, and let's try to connect to one of the hotspot around. WAPI PSK WLAN 0 password 3, and set up the SSID WLAN 0 this one 1. It is trying to connect to this hotspot. Now wait for a moment. Okay, and after the connect operation done, let's new where len 0. Okay, we can see that IP address already changed. Okay, and let's ping Google. Okay, and the demo is done. After the SIM Wi-Fi driver, let's see the QEMU Wi-Fi driver. Compared with SIM Wi-Fi, QEMU Wi-Fi does not support a real wireless card. It only supports simulator mode. Every time when an application initiates a scan operation through WAPI, the driver will read the config files from the BSS file under etc Wi-Fi folder and return the APC information from the BSS file to the application. When the application initiates a connection request, the driver will compare the security mode and the password. If all configuration match, the driver will return success, making the application believe that it has connected to the target access point. The section highlighted in blue on the right is the format of the BSS file, which include basic informations about the simulated access point, such as the BSS ID, frequency, SSI, security mode, SSID, and password. Okay, the second part is address conflict detection. There are two user scenarios ACD works. The first scenario is when a static IP is assigned instead of DHCP, and the second scenario is that if a device failed to get IP address via DHCP, an auto IP function is enabled. Okay, the left picture shows the flowchart of ACD function. Each time when app set up an IP address via IO control, and if the address is not a broadcast address, we will send the app announcement packet to the network to claim that we are the owner of the IP address. And each time when an app request is received and the IP address conflicts with device's current address, we will send the app announcement frame to claim that the IP address is already in use. After an IP address conflict detected, in addition to print the error logs detect the conflict in the console, you can also see the conflict keyword after the inet address if you use ifconfig command. Okay, the third one is PMTU, which is Path MTU Discovery. Let's take a look at the diagram on the right. The data packet needs to be sent from the source to the dest. Potentially, it will pass through multiple routers along the way. Each router may have a different MTU setting. Assume the source wants to send a packet with the MTU set to 1500, but R2 has an MTU settings of 1400. R2 will respond an SMP error packet notifying the source that the packet is too big, please use MTU 1400. And the source then attempts to send the packet with the MTU set to 1400. When the packet reaches R3 realizes that it is larger than its own MTU settings of 1200. R3 will also respond with an SMP error message. After set the MTU to 1200, the source is finally be able to deliver the data to the destination successfully. IPv6 networks Path MTU discovery function is a mandatory feature. Some IPv4 network may also need this feature, because specified IPv4 router might disable IP fragment function, although this case happens rarely. Okay, here is a flowchart of the PMTUD function. When an ICMP packet received, we will check whether it is ICMP destination unreachable with error code ICMP fragment needed. If yes, we will check whether the destination address is in the PMTU table or not. If no entry was found, we will add a new entry to log its desk address, PMTU, and the current timestamp. And if a valid entry is found, we will update its PMTU and timestamp. And each time when dev-if getMTU function is called, we will check whether the desk address is in the PMTU entry or not. And if a valid entry is found, we will use MTU size from the entry for later operation. If not, regular method was used to calculate the MTU size. To make the policies flexible enough, we set up an aging policy for the PMTU entry. The first policy is to remove the oldest entry when the entry space is full, and the second one is remove the entry if no packet was sent to the target IP in 10 minutes. Okay, the third part is the IPv6 enhancement and matter. We spent some time to make several optimizations on the IPv6 features this year. For example, in the past, IPv6 addresses can only be obtained in a static way. After fixing some bugs in the DHCPv6 library, we add the renew6 command to support IPv6 address update. Now, IPv6 addresses can be obtained through DHCP. Both stateless and stateful are supported, but rapid commit is not supported for the moment. Originally, NuttX only supports one IP address per network interface. Now, you can set multiple IPv6 addresses. We also expand the NAT function from the IPv4 networks to IPv6 networks. As I mentioned earlier, this year we spent some time to make sure that NuttX and Matter works together seamlessly. In this architecture diagram, the ticketed modules represent a list of the features that VAA currently supports, and now CI works fine in both NuttX and Matter community. And here's CI job information on both communities. Okay, before end of today's presentation, let me show you what we have planned to do in the near future for your reference. The GSO, GRO, checksum offload, RSS, and ARFS. For USB related, we will implement the NCM and MBM functions. We will also add the net filter functions. Okay, thank you for your time today.
Thank you for this great presentation and great work. Are there any questions?
I don't think that we have questions here in the room. We already prepared Allison as the next speaker.
Just curious, in aging
I don't think that we have questions here in the room.
Okay, thank you. Let's move to the next presentation.
they remove some entries after 10 minutes. And I don't know where the protocol, so I don't know whether it's something in the protocol or.
Maybe you can ask, he's online, right?
I don't know. Do we have anyone from Xiaomi?
Any questions?
Yes,
yes,
there is a curiosity. Please.
Sorry. What other question? Yeah. On the aging policy, one of the last slides, there is a 10 minutes, 10-minute value at the bottom of the slide, and I was wondering.
I'm sorry that the voice is too small. I can't hear clearly.
Yeah, maybe you can ask them.
There is an aging policy in one of the slides. Can you please give us more detail?
The final slide. One of the
last, maybe one before the last.
Okay, you mean the PMTOD section, right? Okay, there are two policies.
We cannot see the slides in this moment, so it's a bit hard to think.
I'm just curious. I'm not sure.
Okay.
Can you hear me better now?
Can you hear me?
Yes.
We can hear you.
Can you?
Okay. There are two policies. The first one is we will delete the PMTOD entry if no any traffic to the destination address in 10 minutes. And because we set a maximum PMTOD entry size, and if the entry is too small and new entry needs to be added, and we will remove the oldest entry.
Yep.
Yes.
Thank you. I was just wondering why 10 minutes?
Oh, I think it's just experience value. There, you can change it according to your user scenarios.
Okay. Thank you very much.
You're welcome.
Thank you for the presentation and for the answer. Do we have any more questions in the room? No, it appears like those were all the questions. Thank you for being part of the NuttX International Workshop, and let's continue. We need a bit of time to prepare the next speaker.
So, hello everyone. Today I will be a presentation about the temperature controlling, and this is a interesting application for many cases. Imagine in this room, for example, we have a system to control the temperature, if you are comfortable or not. We can change the temperature, and this type of application is very useful nowadays. So we can use it in many scenarios. So my name is Alison, and I will start my presentation. So the agenda, it's basically it is introduction about the what is control temperature, how it is designed the controlling, which board I using for this application, the contributions I did it, the implementations, the results, and finally the future works. So the what is the temperature controlling? So the temperature controlling, as you know, guys, it's a device used to hold the desired temperature specified values. As I mentioned before, we have a sensor temperatures controlling check the temperature over time every time for each second, each minutes, and if the value is not selected, is not that we want, we just move into the temperature we want. So the system will select the desired temperature and maintain this temperature during the all time. Well, the system will accept a sensor such as thermocouple or RTD as input and compare the current temperature to desired control temperature or set point. So it exists a set point for to maintain this temperature for this room, for example, that I mentioned. But we have control sensor for different purpose, for cooling or heating, heating purpose, for example. The temperature control are essential for ensuring optimal performance and safely in both industrial equipments and consumer products. So, as I mentioned, it is a very useful nowadays. There are many large applications using control temperature. So basically, we have two types of controllers. We have open loops and closed loops. Open loops, that name the name that you imagine, it is basically we don't have a feedback. So when we don't have feedback, we don't know exactly, we don't have a measures. So basically, we don't know how we drift, how it is the error drift. So basically, without feedback, we don't know how exactly it is the error. Otherwise, the closed loop is we have a feedback, and then we know exactly what is the error and find some ways to to avoid increase the error. Also, we have three types of temperature controlling. So we have the on-off or bang-bang. We have proportional, and we have the proportional integral derivative. It is a PID. It's very useful, and it is more secure and reliable. Also, we have some images showing how it is responsive during the time. So the first image we have the Big Bang or on-off controlling. The second image we have the proportion, which is we have a set point, and then we try to maintain the temperature in the set point. In the last image, it is a PID control, which is create basically a line which it is not does not change along the time. Also, we have also my presentation. It is for to reflow solder. So basically, this application is controlled the headering temperature. We control the temperature during the solder. So the flow curve is a controller temperature profile essential for solder electronic components on PCBs. And this application is very useful because imagine in our houses we want to create a simple prototype, and this we don't have time to wait for produce or manufacture in a big company. So it is very useful if you want to, if you are a hobbyist project, you have a hobbyist project. So the referral curve have five areas. So we have the ramp to soap, reflow, and coding. Also, we have pre-heading. It is the first step. It is the first phase. Yep. Okay. So about the design control. For this project, I try to do something quite simple and fast. So for designing, I try to I create up the power to overheat and measure the time transient of the temperature in the over. Also to parameters the transfer function
We lost the speaker.
let's restart. So the design controller, for the design controller, Thomas, can you hear me?
Yes, now it
Okay.
started.
Okay, so continue. So for the design controller, I create the power over the heat and measure the time transient of the temperature in the oven. To parameters to transceive the transfer function should to parameterize for your controller. So each controller, for each type of controller, we need to check which are the best parameters. For instance, I'm using the signal Nichols method, which it's very helpful and you don't need to involve some method things. So the signal Nichols, it is a method was using to set the PID controller parameters by either analyze the system, the step response. So we just need to using some tools like Octave, for example, and you can check the step response along the time. And we see we have our large set, we have overshoots or not. We just need to adjustments while you construct your PID controller. Okay, so the board that I started ported some months ago, it is a very nice board because we have LCD and it is also S32 base board. So we can use the Wi-Fi and the Bluetooth drivers to telemetry things. But the other things, other fun things, we can have a complete prototype board for this application. So some features we have in this board is the LCD screen, the micro SD card, the RGB LED, the audio for speakers. So we have the amplifier, and also we have the light dependent resistors. So we can control the backlight, for example. And for more information, you can find in nuttxapache.org and so on. Okay, for the implementation, it's I just using some things already implemented on NuttX. I using the Z0 crossing driver, the timers, two timers, the one shoot time and the timer, and I use the Max 6675 driver for it is a thermocouple, so it is very it is a sensor. So basically, this implementation, I just create a thread which handle all the signals, and then signals will we have some controller for the signals, and then we select which it is the milliseconds to start to control the dead cycle, the dead cycle. So this dead cycle, it's very important to have a precise time, because we need a synchronized trigger between the PID and the GPIO. So basically, this is my implementation. So before I really started developing this project, I started testing one by one, and the first thing I tested was the zero cross detector, which is used to synchronize the AC mains to control the power delivery to the load, which is our resistor, and it is basically a zero detect crossing. So as you can see here, we have the example, and also we have the secret that I created, and also we have the oscilloscope image showing the frequency and detect the image, detect the zero crossing. For the timings, I using the one-shot timing to generate the delay to the trigger, which determines how much power was sent to the loader. And also I using this these three examples to give me more basic for this tested. So I tested one by one, and then I move into my project. Here we have three images that I start to controller I trigger the tree-arc, which is we have control to control the how much loader how much power we send for the loader for the resistors. So basically that. And the implementation, basically my PIG implementation, it is that we have the desired temperature and we have the current temperature. So we calculate the error, we have the integrate, we check what is the maximum between the zero and the integrate, and also we define the derivative using the error and the less error. And after that, we already have the P, the E, and the D values. So we just multiply the error, the integrate, and derivative, and then we finally found the PWM value. And for the PID implementation is basically that. There is some results that I could collect it. So we have using the low QD, we have a better behavior. As you can see, it's more like we have a very slowly response. Different the others option, which I increase the QD derivative constants. And yeah. Also, I prepare. Also, it's the final result. And here is my video that I want to show you. Maybe. So sorry about that. So as you can see, the temperature increases. And I'm showing and finally the reflow. And the ramp down. Basically that. Sorry. And also I tested using a transformer that you can see we have some it's not like the resistor response. So basically have this some peaks here. It's normally because we try to control the inductive loader, but I tested, so it's nice to show that. And for the feature works, I try to will improve the mechanism to the trigger, the GPIO. Also, I create a parse to NSH commands to detect for example, if you want to select the QP, QI, QD, and the type of components which you want to use for this example. Also, I will submit a PR to NuttX apps, and the next step it is integrate and LCD to provide the real-time feedback. Guys, it's all, and I appreciate and thank you for this opportunity.
Thank you, Alan. Do we have any questions from the room for Alan? Alison? Alan, are there questions online?
No.
Okay, thank you very much. And we look forward to see some code on the main line.
Okay, thank you.
Okay.
Live.
Okay, good morning, good afternoon, good evening. My name is Dobradan Marius. I am from Romania, from Gheorghe Asache Technical University of Iași, Faculty of Electronics, Telecommunication and Information Technology. And I am happy and honored to be here in Japan. Of these conferences, Japan is a country I wish to visit, but until then I am visiting in the virtual mode with you here today. In this presentation, I will show to you two practical applications based on the real-time NuttX operating system. Both applications were developed in the frame of the NXP Hover Games Challenge competition, in which I participated in all 3 years of occurrence. A competition in which I took first place twice and second place once. The applications aims to detect the people in the area with forest fire, the first one, and the second one is to detect and classify diseases in a vineyard. Both applications are based on an UAV system that was especially developed for each of them. As you know, NuttX is a scalable, small footprint, efficient, very stable, and open source real-time operating system. And it is also, from my point of view, the base for running PX4 autopilot on the flight management board. I interacted with the NuttX at many levels, as you will see in my presentation. And it is important to have the best understanding of it in order to achieve your goals and good results. We go to the first application. And there, one of the most disturbing problems in fire is human death toll. As a direct result, one of the most significant challenges for the rescue and search teams faced during the fire in the wildlands is the actual search for survivors and victims. So, this project aimed to develop a real-time UAV system capable of detecting humans in disastrous conditions like fires. The solution is based on an autonomous UAV that is able to both detect humans and send warnings promptly to a control center. The UAV system will carry out a pre-programmed flight mission by following a planet path above the interested zone, and at the end of the mission, it will return to the landing point. These functions are embedded in the PX4 autopilot. The UAV system was built based on Hover Games Drone Kit, which is a professional development kit produced by NXP Semiconductors. The kit contains all of the required components needed to build a quadcopter, such as frame, motors, flight management unit, power distribution board, and so on. The human detection function was implemented using a Raspberry Pi companion computer. Also, an FPGA system was used to check the detection made by the intelligence system independently. The Hover Games drone can fly autonomously, but based on the radio control link, a ground control operator can take control of the drone, switching from the autonomous mode to the manual mode. By using a telemetry connection, which is a main link with the ground station, it is possible to configure the flight path to supervise and change setting and parameters of the flight management unit, and in this mode to check the status of the Hover Games quadcopter while it is in the air. But most important for us, the human detection from the Raspberry Pi are sent to the ground station based on this link. Communication between the flight management unit and the companion system was done using an I2C protocol. In the case of human detection system, nothing is special or unusual. The hard cascade provided by OpenCV and the linear SVM classifier were used to perform human detection in the video stream. Of course, any other types of detection system can be used here, but there was a small problem, let's say. In a real situation, human detection took between 2.4 and 2.9 seconds, and this detection time is unacceptable. To solve this problem, a multi-thread approach was employed, in which 3 different recognition threads were running on 3 distinct cores of the Raspberry Pi system in parallel. So the main idea was to start this thread using a timer, but each thread was delayed by a third of the detection time. The detection speed improved in this mode, and in this mode I got around 1 frame per second. Right now we have the human detection, and we must send this result to the ground control station. To achieve this goal, a special app running on the NuttX operating system was developed as an independent module able to get the detection result through the I2C bus from the Raspberry Pi and communicate with PX4 based on MIOR messaging. Based on these messages, the information was sent to the telemetry link to the ground control station. So, my app creates a background task based on the first function, and this new background task runs independently from the parent. In the background task, I created and initialized several objects, such as an unnamed semaphore and a timer. This was a point where I started to fall in love with the NuttX operating system. Due to the compliance with the POSIX standard, all the interfaces from these components are identical to the one found in the Linux distribution. So, to develop this app, I first created and configured a timer. Based on this configuration, the kernel of the NuttX operating system will send a signal each time when the timer expires. In the second section, the timer expiration value are set and the timer is armed. In the last step, the signals and my function association is made based on signal action system call. In this function, the human detection information is obtained through the I2C bus, and sent to the PX4 autopilot based on the mirror messages. Of course, in the end, the PX4 autopilot sends this information to the ground station based on the Mavlink protocol. In conclusion, it is very easy and straightforward to develop code in the NuttX operating system, and all the knowledge acquired by you in the frame of any type of Linux distribution can be used in NuttX without any difficulties. So let's go to the second application. The main idea is that there is a growing need for food worldwide, and this need requires the development of high performances, high productivity, and sustainable agriculture, which implies the introduction of new technology into each stage of plant development. However, many elements affect crop development, like the one presented on this slide. But one of the most important is the existence or not of different types of diseases. In this project, I developed an intelligent system to assess the healthiness of vine based on the characteristics resulting from the analysis of the vine leaves, such as texture, shape, or color. The intelligent system presented here is able to detect two different diseases. The first one is blaster mite, which is generated by a mite species infecting grape leaves. This disease is also a vector for other viruses that affect vines. The treatment for this disease should be applied when the first mites appear. If they are allowed to develop, they will do so quickly, mainly because this mite has between 5 to 7 generations in a year. The second detected disease is grapevine leaf roll disease. Is presented in the second picture. This disease is one of the most important grapevine viral diseases affecting wine grapes worldwide. The main problem with grapevine leaf roll diseases is that there are no ways to cure an infected vine, and there is no chemical control for grapevine leaf roll disease. Therefore, the only solution is to remove and destroy virus-infected vines. So, as a direct conclusion, the field survives, and the detection of the grapevine leaf roll diseases are the only valid approach used up to this moment. The grapevine leaf roll diseases is also considered one of the most economically destructive grapevine virus diseases. There are many estimated of the economical cost worldwide. Some estimated loss ranges from $3,000 to $226,000 per hectare. In another estimate, the losses are between $25,000 up to $4,000 per hectare. And in other approximations, the loss is up to 77% revenue decline. So, as a direct conclusion, this intelligent system is important because a timely diagnosis of accurate identification of grape leaf diseases are decisive for controlling disease spread and ensuring the grape's healthy development. Moreover, the early detection of diseases will determine the use of pesticide only when necessary, with a positive impact on the environment. The intelligent detection system is supported by an IMX8M+ development board, known under the name of NEFQ+ development system, carried over the entire vineyard by an NXP Hover Games drone that was presented before. The development board also has a neural processing unit, NPU, on which the deep neural network is executed in real time. At the level of the IMX8M+, the functionality were implemented using the support of Robotic Operating System version 2. Additionally, ZeroMQ client application and ZeroMQ server were used for debugging the developed application in real time. The system incorporates a deep sensor as to guide the drone to the rows of vines. For vines planted industrially with mechanized soil maintenance, there is a distance between rows between 2.2 up to 2.5 meters. So we have plenty of space to fly. A Google Coral camera was used for plant anomaly detection. Of course, the depth sensor has also an RGB camera that could be used instead of the Google Coral camera. Still, initially, the functionality were implemented by using both cameras to ensure that the data stream could be received without any lags or any type of problems. Next, I included a LiDAR light type sensor in the system because maintaining a constant altitude through the GPS and the barometer sensor is not so accurate. The components that implement the software part of the UAV were developed as a single ROS2 package having 4 nodes. And all of the communication and synchronization between nodes were done through the topics. The detection system is based on the TensorFlow Lite model that runs on the help-run node. The detection system starts when the UAV drone is set in the off-board mode. The node takes note of this fact from the flight control node through the flight off-board topic, and in this mode, the detection process starts. The help-run node published 2 topics related to the detection process, detect VTs, and the second one is detect left roll. These 2 topics post the area of leaves for each class detected. This publication of affected leaf area can be used to create a real-time map of the extent of crop damage. The flight control node is connected to the PX4 autopilot, being able to control the UAV based on the velocity and position modes. It is also able to know the status of the drone at each moment. This node can arm, disarm, take off, land, etc. the drone according with the necessity resulting from the off-board control. Each of the following nodes, video publisher node, flight control node, health plant node, has a specific topic for publishing images required for the debugging purposes. The broadcast node can subscribe to a specific image topic and stream the images to the ZeroMQ video server through, of course, ZeroMQ streaming protocol based on the Wi-Fi link. Mainly because in this project, I want to detect only 2 types of leaves, and because this type of leaves do not belong to the category on which a classical deep learning networks were trained, like person, car, airplane, bus, train, boat, bird, cat, dog, and so on. I used the transfer learn paradigm. So I use MobileNet version 3 deep neural network, which is widely used for image detection and recognition. This neural network already has trained layers that can identify different features, like outlines, curves, edge, and so on. Training these layers required a lot of training data and also required a lot of training time. But using all of this already embedded knowledge, I only retain the last layer. I only retrained, the last layer, which was replaced with a new one, with outputs for detected element probabilities and outputs pointing to a specific area in the input frame. So, in order to train the last layer, a new training database with images was created for these 2 classes. 80% of the images from the database were used for training and 20% for testing. 4. The image annotation, mode and selection, according to the desired accuracy, because you have the possibility to choose different type of models. Model training, model optimization for efficient neural processing unit execution, and model validation. I use the EAQ environment that is presented here. Following the training process, the detection performances was a little bit more than 86%. Okay, but keep in mind that this project was something of the proof of the concept. Thus, I was able to prove that the functionality of this approach. And of course, this project can be applied in the similar way to assess the health of the fruit tree, maize, rice, or any other plant based on the state of the leaves. Right now, I'm working to increase the classification performances. From the point of view of the NuttX operating system, I had less interaction with this operating system in this particular project. My application was developed entirely on the companion computer and communicate with the PX4 autopilot through the micro RTPS bridge, real-time publish-subscribe bridge. For example, I interacted with the NuttX when I built the autopilot. Here you can see the menu config tool. Of course, here is a graphical user interface variant that was used to modify the PX4 board configuration, adding removing modules, drivers, and other features like NuttX components. In addition, the client component of the micro RTPS bridge were executed at the boot time of the flight management unit based on the NuttX OS features. Moreover, I extensively use the NuttX integrated shell interpreter to launch different components, drivers, or to check the state of the system, like CPU and memory usage, the state of the GPS, to test the motors, scan for I2C devices, to list topics, to list the content of the topic, to check the state of the Mavlink connection, or to erase the flash memory. Okay, in the end, in conclusion, the NuttX operating system is an essential component of any PX4 UAV. In my case, of the hover game drone produced by an SP company. And the last one, the most important one, a deep understanding of this operating system will help you to build a UAV system that is as safe, effective, and reliable as possible. So that was all of my presentation. Thank you. And if you have a question, I'd be happy to answer to you.
Thank you for the presentation. Let's see if the room has questions. Do we have questions for Mr. Dobre? It looks like there are no questions. Thank you very much for being with us this year, and we hope to hear more from you next years.
Okay, thank you very much. And I hope next year to be there with you. Okay, excuse me.
Sorry, it appears that we have a question.
Yeah, I have a question about the these projects. In the beginning, you said you won some competition using the
yes.
the NXP hover, and how was that competition? And can you tell us a little bit more about the event itself? Because I'm more curious about that than the things you did in NuttX directly, because it's already open source, right? Many things.
Yes.
Already.
As you saw, excuse me.
Okay, go.
As you saw in the second slide, of course, one moment. Okay, as you saw in the second slide, one moment. Okay. Okay, all the components that are included in the project are open source. The competition was a very competitive one because, for example, in the first year, the NXP company builds a flight management unit. And they want also to test this flight management unit, and there was a lot of unknown facts. And we were together, I don't know, I think more than 100 competitors, and each of us proposed some kind of project related to a specific idea that was each competition each year have a different goals to develop. And for my point of view, because on the first competition, it was the first time when I get in touch with the PX4 autopilot, to all the components that are inside, to the Mavlink protocol and so on. And it was for me, it was very interesting because I learned a lot of things. And based on these things, I developed a project that my first idea was to make something different. But I was unable because at that point I did not have all the technology required to build this. And I go to the first project that I was presented to you. And for me it was, and it's also very challenging because you must to build the project and to develop from the start to the beginning to have a flight hover games drone. And it is a little bit difficult because I had a lot of crashes, and I start to rebuild my drone. I don't know, first time I 3 or 4 times. In one time I lost one of my drone in wildness, and I was unable to find it. And I think that the most important, let's say, gain from my point of view, that is I was able to learn a lot about NuttX operating system, PX4, and so on. And from year to year, I was able to develop something that was, let's say, a little bit more complicated from the previous year. And in this year, the competition was not started yet. And I think in few months, they will publish the competition on the hover games on the Hexter.io. And I invited all of you to participate it, mainly because it is very challenging and you'll learn a lot of things, and it is very fun. Okay, I hope that I answered to your question.
Yeah, I enjoy it. Do you have some videos from that competition that you want to share with us, if you can?
Yes, I have. I have one moment. I have my one YouTube channel, and there, because we must to prove at each stage that our project is doing what is intended to do, and for these reasons, all of the competitor must to publish video with different stage of the development of their project. And one moment, I will show to you. One moment. Okay, I will show to you something that was, let's say, a little bit challenging from my part. I lost a lot of time in order to solve this problem, but was fun. One moment to share my desktop. Okay, not this. Okay. So here is one of the problem I encountered when I start to develop the project. For example, if I fly the drone without any Raspberry Pi connected to the flight management unit, I had no problems, and the drone flight very well. But when I connected the Raspberry Pi, you see that the drone starts spinning, and the main problem was mainly because on the same I2C bus, it was connected also the Raspberry Pi and the magnetometer sensors. And the magnetometer sensor and the Raspberry Pi works on 2 different frequencies, and the driver that connect to the same time to the Raspberry Pi system and to the magnetometers must change the frequency from, I don't remember very exactly, but from 400 kilohertz from the Raspberry Pi to maybe, I think, 1 megahertz for the magnetometer. And this, when that kind of changes was made, the system was unable to change correctly the frequency, and I had some kind of problems. And these problems was able to solve with it, but after, I do not remember exactly, for my point, it took around, I don't know, 3-4 weeks in order to be able to understand the problem and to be able to solve the problem. Of course, I have many other videos. I invite you to see my channel. This is my channels, and I had here, for example, if you are willing to compete in the hover game competition from this year, I have a lot of videos when I present different type of tricks in order to be able to fly without any kind of problem, to solve different problems. And for example, here you'll see that I have, I don't know exactly, but I have around, I don't know, 20 video that I present different problem that I encountered in the moment when I was able to solve different problems. And I invited you on my channel, and there I have also different videos that are related with my work as a faculty, with different projects built by my students and so on.
Yeah, and you also are very active in the Hackster.io, right? And it was there, it was in the Hackster.io that I found it.
Okay, so and you meet you and you invited me to this workshop. Thank you very much for the invitation.
Thank you. Douglas, can you please copy the link and share here in the...
of course.
In the,
yes.
Be easy for me.
Yes, I will copy in a short moment. Okay. Okay, thank you very much.
I really appreciate your presentation. It was really cool, and you did many difficult and interesting things. And I suggest to everybody that want to learn NuttX to really develop some projects using that. This is the only way that you can really learn NuttX. Otherwise, you stay only swimming in the surface of the lake, of the NuttX lake.
Yeah.
Okay, I put the link in the chat.
Thank you very much.
Thank you.
Thank you very much. Have a nice day. Bye.
You're the same. Bye bye.
Bye bye. We are 1 hour ahead of the time,
yes.
And the next speaker is not here yet. So, what is you suggest? Maybe you can
would suggest to take a break, get some coffee. We still have some coffee in the other room, and maybe we should try to come back in 15 minutes. Maybe we get the
I sent message
last speaker. Yeah.
But I think it's from Bulgaria, and he's a little bit early there as well, I suppose.
Hello Gabor, thanks for joining us. We are now in the back room. If you are ready, we can start the presentation. We are running a bit ahead of the schedule.
Okay, can you hear me now?
Yes, we can hear you. Thomas, are you around?
live.
I need to go review for some reason.
So welcome everyone. My name is Gábor Kismámosi, and I'm the original author of the LVGL library and the CEO of LVGL LLC. In my presentation, I will talk to you about how to create your first UI project with LVGL using NuttX. But let's start with what LVGL is. So LVGL stands for Light and Versatile Graphics Library. So it's a graphics library which helps you to create beautiful user interfaces on resource-constrained embedded devices. I can proudly say that right now, LVGL is the most popular free and open source embedded UI library. It's a full-featured solution because it contains more than 30 built-in widgets, including bars, sliders, charts, buttons, drop-downs, keyboards, text areas, and many others. Basically, what you can see in an Android or iOS application can be realized with LVGL as well. Besides that, LVGL has a quite powerful style and layout system. These layout and style systems are heavily inspired by CSS. If you are not familiar with it, CSS is the styling scheme of the web pages. So the same technologies which makes the web pages so powerful and responsive are available in LVGL too. In the practice, it means that you can choose from more than 100 style properties to style all the parts of the widgets in various states, and you can apply transitions when the widget changes state. So you have a great freedom for deep customization on the appearance of the widgets. In case of the layouts, it means that LVGL adopted the most or the latest layout technologies of the web, meaning the flexbox and the grid layout. Using these layout systems, you can easily position the widgets, and you can also change their sizes automatically in a responsive way. LVGL also comes with a powerful typography system. It supports the Asian languages like Korean, Japanese, or Chinese, or the Arabic languages with right to left and left to right writing direction support. You can also mix the two. And of course, it supports the Latin-like languages as well. So as I already mentioned, LVGL is a free solution. Its source code is fully available on GitHub as well, and is distributed under an MIT license. In the practice, the MIT license means that you can use LVGL for commercial purposes as well without any issues. All you need to do is adding a sentence in your documentation stating that we have used LVGL to create the UI of this product, and you don't need to pay any licensing fees, subscription fees, royalty, or anything else. I also mentioned that LVGL is quite popular today. It means that according to the statistics on GitHub, we can see that LVGL is downloaded in every minute by someone. And besides that, it's already supported by the leading players of this industry, including the largest chip vendors and operating systems like NuttX as well. LVGL is platform independent. Therefore, you can use it with basically any modern microcontroller, microprocessor, with any real-time or normal operating system, and you can drive basically any kind of displays, like an OLED display, monochrome display, e-paper, TFT displays, or monitors, if you like. If you want to use LVGL on its own, you need to have software developer skills, because you need to call functions like button create, set position, set size, so you need to write code. However, there are multiple third-party UI editor tools that you can use to speed up the development process, with SquareLine Studio, which is a subscription-based tool, or Easy Studio, which is a free and open source solution. You can use your mouse to put together a UI in a drag-and-drop fashion. And finally, I'd like to tell you a few words about the services that we are doing. If you like, we can help you with creating a UI design for your product, implement your UI with LVGL, of course, and if you have both UI designers and UI developers as well, we can help you with a consulting service to help you answering some questions help you to optimize the performance and things like these. On this slide, you can see a few demos that we have created with LVGL. However, if you click on this link, you can go to our new website. It was released just a week ago. And if you scroll down a little bit, you can see some demos here, which are actually interactive. So you can click on these switches, for example, drop-down list, and you can see how the widgets looks like and works in the practice. We have a keyboard here. This one is a password box. This is how the widgets look like out of the box. So for example, if you create a switch, it will look like this. But as I already mentioned, you have a lot of opportunities to change the appearance and customize it as you like. Here we have some charts that you can slide, and we have this popover here, a similar bar chart, and some gauges. We have used only a few images on this UI, therefore you can change the appearance, for example, the primary color, very easily in runtime as well. The other demo that I like to show you is a smartwatch that we have designed for NXP. It was created in SquareLine Studio without writing a single line of code, so even a designer is capable of creating these UIs. And here we have a thermostat UI. Here we haven't used any images at all, so all these gradients and shapes and shadows were rendered by LVGL with its built-in software render engine. And we have the music player application. Here these jumping bars are quite interesting, I believe. Yeah, and the printer demo at the end. So, at the beginning of this year, we have released LVGL version 9. It comes with a lot of great updates. For example, we have updated the rendering architecture. It means that now when LVGL wants to render something, it can use RTOS function calls as well during the rendering process. Therefore, it can free the CPU while, for example, a GPU is working in the background. Besides that, with the new rendering architecture, you can use multiple CPU cores for rendering as well. And finally, now we have some built-in assembly options to replace the slowest and most resource-hungry parts of the rendering with some dedicated assembly instructions. We also have built-in drivers in version 9. You can use the most popular display controllers like the ILI 9341 and similar ones with SPI parallel port interface. These display controllers already have a frame buffer built in, so you don't have a lot of RAM inside your microcontroller. So if you have a display controller like this, you can just create an LVGL initialization code for it by a single line of code. Besides these low-level display controllers, you can also use some high-level drivers like Linux frame buffer, DRM, Wayland, and these kind of things. These are also just a single line of call, a single line of function call to create a new window where LVGL can render something. And finally, a few words about some rendering features and widgets. I like to highlight the new gradient engine, but instead of just talking about it, I can show it in our documentation. If you go to docs.lvgl.io, you can see a detailed documentation about all the main parts of LVGL with a lot of examples about the styles. So we are in the style section right now and looking at the examples. Here we have some examples for the new gradient engine. So now you can use this conic gradient, not just a horizontal or vertical gradient like in LVGL version 8. So without any images, you can runtime generate this nice effect. And yeah, maybe it's not obvious at the first look. Why is it better to use a software rendered gradient instead of an image? So if you're using a software rendered gradient, you can update it at runtime. You can change its colors. You can change any parameters. You can animate it if you like, and you don't need to embed a lot of images into your Flash. If you like, you can pre-render these into a RAM buffer to make rendering faster in general, but it's really up to you to decide how you trade off with memory and time. Here we have a radial gradient used as the background of the screen. And here you can see some other gradients applied on buttons. So this is the old and basic horizontal and vertical gradients. However, we have this linear gradient where the gradient has an angle, and you can see here a radial gradient where it even has an offset. The other feature that I wanted to show you is the Lottie animations. So the Lottie animation is something similar to GIF, but it's vector-based and full colored. So the GIF images are using a 256 colored palette at best. However, with Lottie animations, you have the whole color spectrum with ARGB 8888 colors, and as it's vector-based, you can scale it as you like. To add this Lottie support to LVGL, we have used another library called SORVG. This is quite popular already, and it has a lot of features for great vector rendering, Bezier curves, strokes, and all this kind of stuff. And it has support for Lottie animations as well, so it was quite handy to, once it's already integrated to LVGL, to use it for Lottie as well. As usual, similar to the other widgets, to create a Lottie animation, you just need to call a function like lvLottieCreate, pass a parent widget as a parameter, is the current screen right now, and you just need to set its data to some array where the actual Lottie animation is stored. And finally, you need to assign a buffer where the animation will be rendered. Here you can also control where you store this buffer in internal RAM, external RAM, so you can set it up as it fits the best to your system. Okay, let's talk about how you can use LVGL in NuttX. Here I also need to mention the great work of Xiaomi. You might know that Xiaomi have published their operating system called VAA OS, which is based on NuttX, and for UI they are using LVGL. So the Xiaomi developers or engineers have already contributed a lot into LVGL, but as they are using NuttX as well, they have added a very good NuttX support in LVGL too. What I mean by that, for displays, we support NuttX LCD interface and NuttX frame buffer device support as well. So in a quite NuttX-ish or Linux-ish way, you can just use the normal LCD device or frame buffer device and create an LVGL display for it. Similarly, for the input devices, you can use the input devices of NuttX, or we support UTouch as well. In case of images and fonts, sometimes you need to deal with cache mechanisms, because when an image is updated, you need to clean it from the cache. So LVGL supports NuttX cache API as well to automatically invalidate or clean the cache when needed. We also have a profiler which helps you to show what LVGL does in a visual way. It will show some function calls and the functions which are called from there. You can measure the time and see the whole hierarchy. And for this profiler, we have a one-liner initializer for NuttX as well. So you just need to call a function, and you can use LVGL as profiler because all the timers, time measurements, and the printing and everything will be set up for you. If you would like to measure the CPU usage, normally LVGL can do it out of the box as well, but it's not aware of the operating system because it just measures how long did it take to execute some of its functions. However, if the operating system yielded a task and did something else in the meantime, LVGL doesn't know about it by default. So you can give LVGL a special idle measurement function, which will report the idle from the operating systems itself. To do this, we have ready to use NuttX function as well, so you can enable it quite easily. And finally, LVGL supports libuv as well. So all the power management related stuff for low power devices is available. You just need to enable a single config in LVGL's configuration file. Let's see how it looks like in the practice. So this is how you can set up a basic LVGL UI in the NuttX ecosystem. So first, we have a descriptor that we need to initialize to the default values. In the descriptor, you can set the frame buffer's path. Let's say it's the FB0 as usual. And you can also set a path for an input device. It can be a touch, it can be a mouse or something similar. After that, you need to actually create an LVGL display and LVGL input device from these settings. You can do it by calling LV NuttX init, and the result will be stored here. Here you will find a pointer to the LVGL display and the pointer to the LVGL input device and all the related stuff. And finally, you just need to call a UV loop passing these results. So it will take care of everything, create the timer, pause it and resume it when needed. And that's it. Before calling this loop, you can add your LVGL UI code. We have a lot of built-in demos, built-in examples, so you can try out a lot of LVGL stuff out of the box. It's not really our merit, but the merit of the NuttX architecture, that you can very easily change between various architectures or devices, or let's say targets. So if you would like to try out LVGL on a Linux environment, you can configure it for a simulator and targeting LVGL frame buffer. After that, you can just make it and run the NuttX application. Later, if you would like to switch, for example, to an ESP32 target, of course, you need to execute a clean. And after that, configure it again for the desired, in this case, ESP32 target with LVGL, compile it, and flash it to the ESP module. And this is how it looks like in the practice. So this is an ESP board where we have created a small intro animation. And this is a basic LVGL example to show you the scrolling and offsetted list. And that's it. And finally, I would like to tell you a few words about the things that we are working on right now. On the first slide, I was talking about that if you would like to do, use some UI editors, you can choose from some third-party solutions like Squareline Studio or Easy Studio. However, we realized that we should have our own solutions for this. There should be an LVGL official UI editor toolkit. And we have just started to work on it right now. In the past few months, we were working on the business background and the financial aspects, but a few weeks ago, we have jumped into the actual development. So this is how it will look like and how we imagined it. First, it should be a quite light and developer-centric UI editor toolkit. By developer-centric, I mean that we have clearly realized that designers are always using Figma. They are not really into using some developer-related or close to development tools to put together the UIs in drag and drop fashion. They want to stay in Figma. Figma is the most popular UI designer today. So all the designers are using it right now. So our goal is basically to create a good bridge from Figma to LVGL, because on a larger scale, usually there's dedicated designer team who created the design in Figma, and the developer's task is to re-implement it in, let's say, in LVGL. So our task is to help integrating the Figma design into an LVGL environment. As it's a developer-centric tool, it's very important for us to make it work very well with the normal and usual version tracking systems and have a good integration with GitHub, GitLab, or Bitbucket as well. Here I also need to mention that as it's developer-centric, the generated code, the quality of the generated code is very important for us. We just don't want to have some bulky and dummy and do not edit UI code from the editor that you cannot really touch, but this UI editor toolkit should work together with the developer. It should help you when it's really difficult to do something from code, because it's easier if you immediately see what you are doing instead of having 100 iterations like compiling, running to see if the positions are correct. So it should help you with the visual things, but should give you the freedom to implement the logic as you wish in code. We also realized that basically all the vendors are migrating towards VS Code. So this editor should work as a VS Code extension as well. But if someone is not using VS Code, we should have a standalone desktop application as well. Besides that, we will add a plugin system which will allow vendors or some OEM companies to add some custom plugins for their special workflows or hardware or anything else. And that's it about LVGL in short and how you can use it with NuttX. If you have any questions, please let me know. I would be happy to answer them.
It was a really nice presentation, and I want to thank you every time I see you, because I don't know if you remember, but about 7 years ago, 2017 or maybe 2018, I don't remember exactly, when I discovered LVGL, and I tried to trying port it to NuttX, and I contact you, and you was very helpful to help, and actually you did the port to NuttX yourself, because I was not so familiar with the LVGL. It's still not so too much, but today I use it a lot, and it's a really good library. I developed a project a few years ago using LVGL, and it was in production in United States currently. And so, yeah, you deserve that success you have, because you are a really good guy and really smart and have great skill.
Thank you very much. Yeah, I do remember that first NuttX implementation or integration. Yeah, 7 years ago. Yeah, I published LVGL in 2016 on GitHub. So NuttX was the first operating system who integrated it, and it was. Yeah, and it was it was a big step for me as well. Yeah, you know, the first time working with a huge project, and I was super excited that LVGL will be integrated into something large, which is already existing and used by a lot of people. So yeah, thank you very much for that initial boost. It meant a lot.
Yeah, and I hope you come to our event in person in next year, because we are expecting you here. But we know it's a long trip for you, and you have family, and as you said, baby and small child, so it's a little bit difficult. But let's see for next year, and it should be nice, and we hope it happen in Europe, so it will in your neighborhood, in your
closer.
Yeah, very close, in your backyard.
Let's see what we can do.
Yeah, it would be very nice to meet you in person, guys, really. So I hope that we can make it next year.
Thank you. And about the this demo that you show, do you share it in GitHub that we can test? Because it seems really nice to see the NuttX logo showing up. Maybe you can do some like some default application with it, including NuttX, for example.
Ah, sure. If you like, we can send you a pull request to the LVGL demo of the NuttX applications.
Yeah,
it should be interesting. Yeah,
should be really nice. Really cool.
Okay, we can do that.
Let's see if we have some questions in the room. Does anyone have questions regarding LVGL?
Who he has tested or used LVGL already? Alison? Only Alison? Or maybe
I run some samples, but nothing.
Oh, you use the default sample, but okay, not play with. Yeah.
I have a question regarding the major version and the last version. What did it actually change? We have more animations, demos, something like that.
In the last major version, which was version 9, we have changed the rendering architecture as I have described. It was the largest or the most impactful change, I guess, because now LVGL can work better with software rendering and GPUs together. So let's say the GPU can render something on one area of the screen, and the GPU can render this area, and the CPU can render another area in parallel. So the only limit will be the memory bandwidth. It was a huge update and required like rewriting the half library. Besides that, we have added a few widgets. We haven't really touched the style system, which is important because, you know, we are always having some breaking changes on the major versions, but at least the style system remained the same, so it's easier to migrate. We have also changed the driver layer a little bit to make it more suitable for the built-in drivers, make it more runtime. We have worked better with runtime display creation. Now you can change the color formats in which you are rendering in runtime as well. For example, if you have multiple displays connected to a single microcontroller, you can have one with eRGB 8888 and the other with RGB 565 color formats. So these are smaller changes, but still important. But if I needed to highlight something, it would be the new rendering architecture and the introduction of the vector graphics library SORVG that I have also mentioned. So now we have a lot of vector related stuff in LVGL as well.
Cool.
Okay, just one more comment. I have been working LVGL since the version 7, I guess. So it's amazing. Yeah, it's just comment about that. So, but it's amazing. You're working. It's an incredible library. If I have some advice for this room, please using the LVGL UI project. It's a very lightweight library, and the API also it's very powerful. So I thank you, Gabo. Also, it's a pleasure meet you, and yeah, have a good weekend.
Yeah, thank you for the feedback. It's really happy to hear that you like it and find it powerful. It was really nice to see you guys. I hope you have found my presentation interesting. And next time, if you would like to do some UI related, I hope LVGL will be an option for you.
Okay, thank you, Gabor, for the presentation again. About the this breaking that you mentioned, for example, when I try to run some application from version 8 or 8.3, I need to do some modification to get it running in version 9. Do you have some plan to make something like OpenGL that more freezing API, that don't change too much over the time? Because it should be nice to have at least some basic API that we can rely and know that they are not to be deprecated or removed over the time. Do you have some plans or some idea for some free, like LTS or free zone version API?
Yes, actually, this concern was raised by the developers of Xiaomi already, because they are also suffering with the API breaking. Even if I consider these changes minor, if someone has a huge ecosystem where multiple applications, multiple products, multiple departments of the same company are using LVGL, it's a hell to, update everything and clean out all the libraries, versions, and align them again. So yes, to make it simpler for them and of course others as well, we have decided to keep the APIs backward compatible for 2 major versions. So even if we deprecate something, it will be introduced and you will have 1 new major version to adapt to the new API.
Yeah, it should be nice because, for example, I think the great benefit of NuttX, for example, is the POSIX. If you develop something in POSIX 30 years ago and you can still running it today. And I think should be nice to have some great graphic library as LVGL, very stable, and we can use it for many years without breaking the code or modify things. Maybe the version 9 or after the version 10, it can be stable and you can add more function, but the basic function that is there is still the same.
Yeah, definitely. We need to pay more attention to this for to backward compatibility. And yeah, being POSIX compatible is, I think, the dream of all the developers to really do something now, and 30 years later it will still work because POSIX still POSIX. It's really awesome, I think, and makes a huge difference for developers, especially for large projects. I don't know the details, but I think it was one thing why Xiaomi, for example, have chosen NuttX, because it's so mature and stable.
Yeah. There are many other RTOS out here. If you go to Wikipedia, there's more than 2,000, and NuttX is one of the great RTOS exactly because it has this POSIX compatibility, and it really shine on that, and also be very similar to Linux, make things easier for people that are coming from embedded Linux, for example.
Oh, yeah. Yes. By the way, do we have a few minutes? Because I also would like to ask something. Yeah.
Oh, yeah, we have.
Once NuttX is so Linux-like, I wonder if there is an option to install applications or run multiple applications as you would do on a normal PC. It's very important, for example, for smartwatch manufacturers when like an alarm or a messenger or something like that can be installed or uninstalled in a dynamic way. Do you have an idea for this maybe?
Yeah, actually my dream for a long time was create some NuttX distribution like you have for Linux.
Mm-hmm.
And we can use, you know, like the OpenWRT, for routers, they have the OPKG, the package like the apt-get, so you can install application and so on. And NuttX can do that because we have ELF dynamic loading application, so we can create something like that to create many applications and do like firmware update only for the application or one specific application, for example. But I don't know. We have many names for this distribution, like Nutcracker or Pistachio, many things related to nut. But we never have someone or many people interested to do that because it's not a project for a single person. I think it needs to be like Debian. You need to have many developers engaged on this challenge, because
I think that a proposal like this should go to the dev mailing list, and then we will see if people are interested in creating either a distribution or having the ability to run install multiple applications from external sources. There are a few ways of doing it. I think that the best would be to take it to the mailing list, and then we will see which option is better for us and what the other developers think about it.
Yeah.
Okay. Do you also use the GitHub issue tracker actively, or rather the mailing list should be preferred?
We use it, but the preferred way is the dev mailing list, because then you have access to all the developers, and also the communication is archived so that we can document why we added something. So the primary channel is the dev mailing list.
Yeah, for general discussion, it's better to use the mailing list. But for example, we are using it actively for issues that people find, and we are fixing issues based on issues in the GitHub. But in this case, it's most like a proposal than an issue itself.
It's a feature.
It's a feature. It's not a bug, it's a feature.
Yeah, okay, clear. Yeah, this feature was actually requested by multiple smartwatch manufacturers from us if they can do it with LVGL, and I needed to tell that it's not really an LVGL thing how you replace a snippet of the binary on the microcontroller. If you can do it by adding two numbers, you can do it with LVGL too.
Yeah, actually, my previous idea was doing it using some text or like curses test mode. But now that we are jumping in the idea, we can do like a graphic installation like in Linux today. We're using the LVGL, and so the people can select, I want this and this application, and just build and create the final board with all the applications.
Let's take it to the dev list, and we should also consider that most applications for NuttX are headless, and they are usually quite small, so you cannot connect a display.
Yeah, I think it's like Linux, right? We have both scenarios.
Let's take it to the mailing list, and then we will see what the project thinks that is the best way.
I agree.
Sure. Okay, we will. Maybe we will need some time to send it, but I will keep it in mind for sure.
Right. Are you in the NuttX mailing list? I don't know if you are already there.
Not yet, but
okay.
Yeah, I can.
I send the link. Is in the nuttx.apache.org. There's a community.
Let's send the link.
We send the link, and you can. Yeah.
Okay,
can
awesome.
enjoy.
Thank you.
Thank
Super.
you
Thank you
for joining us, and really good presentation as all you do for LVGL is so great. We are very happy to have you here. Now, once again, have you help with our project. It was really important for us to have LVGL support on NuttX.
Yeah.
It opened new doors.
Okay, likewise. Thank you very much for having me. And yeah, I hope you had a great conference and see you in person next year.
Yeah,
Thank
see
you.
you. Thank you.
Okay, bye-bye.
Bye-bye. Okay, I think we are mostly done for today, right? And guys, it was a long journey. 2 days of presentation, right?
Quite long.
Yeah. And this year we have 30 presentations. So it was really great.
I think that it was the biggest number of
Yeah,
presentations
for
that
all
we
the
had.
all the previous
Yeah.
year. Last year was 20 or 22, if not wrong. But this year we have almost 10 presentations more.
If we end up with more than 30 next year, probably we have to extend the event
Yeah,
to
maybe
3
3 days. Yeah.
Yeah. It feels like it was a bit tiring. I see people being tired in the room.
Yeah.
It was more than a normal session. Also, we ran without pauses.
But you know, normally most people here are from Japan, and they sleep all the time inside the metro or outside. They are not tired. They are just resting a little bit.
I think that we should also consider the people that watch it online and wanted to be live with us, because we had quite a high number of live viewers. And we should also consider the people that will watch it in the following week and months. So we will do our best. We will split the event into presentations, and then we will link it presentation by presentation to the schedule on the developer events, NuttX events webpage. I'm sorry, I'm tired. So that you can find the presentations that you need, and you can have an easy reference finding exactly what you need, especially since we had to run packed without pauses, and it may be a bit hard to navigate the material.
Yeah. And any other thing that we need to? Yeah, I think this year it was very complicated for people in Brazil, for example. I think we have a great audience there, right? Normally in previous year, we have 50, 80, or 100 people only in Brazil watching the presentation, the event itself. And this year, we saw it was they are not able to do that because it's in the in the middle of the night or after the midnight. So, but maybe next year in Europe, for example, it will be okay for everyone. But in the other hand, this time Japan, China, and India can attend more easily. Yeah.
This is the reason why we promised that we will have each year one event on each continent to be time zone friendly. And if we look at the historical statistics, we have around the same number of participants since we started the online workshop. If you count 24 hours, because some people will attend live, some people will watch in the first 24 hours to see what happened. So I think that overall we have a quite steady community, and we are grateful for having such a community, because that gives us the reason to organize this event. And we hope that next year we will get more people that are interested in helping us
to organize the event, to become organizers. Like every year, we will post an announcement on the dev mailing list, and maybe you want to join. This year, we had Hallison, which helped a lot with the organization.
Thank you for the help.
Yes. Also, we got Thomas Sederom, which this year took my place and hosted the event online. So everything that you see going live to the internet goes through his streaming.
Thank you, guys. The pleasure is mine. Respect for Gregory Nat for creating and sharing NuttX. Thank you, Japan, for hosting. Kawaii. See you next year.
And thank you all the
participants
that come here, and thank you for those that take your time to prepare some presentation and do a great work here. Thank you, guys.
I would like to also say thank you to Ishikawa-san, which was our ad hoc photographer. He took all the pictures that you will soon see on the website.
Yeah, good. Great.
And also we should thank Sony for hosting us in their office. As probably I should repeat, I'm a Sony employee. And I'm happy that we were able to host the event here in Japan. I'm located in Europe. So Sony Japan offered the venue and offered us 2 days of quite nice, quiet room, all the connectivity and everything that we needed to be able to stream. So I think that Sony also deserves a clap.
Yeah.
Okay, that was Thomas. And the biggest thank should go to Greg.
Yeah, Greg knows is the father.
Yes, we try to invite him both in person. I sent the invitation quite early, and he said that unfortunately it's not possible to come.
Too late in Costa Rica.
And I sent him the invitation to join the speaker lounge, but it is a completely wrong time zone for him.
Yeah.
So it's sad that we couldn't have him this year with us in person or virtual.
Yeah.
I really hope that we can have him next year to join us, at least virtually.
Yeah, because
hopefully
all 5 previous workshop, Greg show up and talk with the people. Yeah, it should be nice to have it.
A big thank to Greg.
Thank you, Greg. Actually, if Greg didn't have create NuttX, we are not here. Yeah. We are not in the moon. And my project will not be easy to do because there is no VNC server to use as reference.
Yes. So with those words, I think that we should thank everybody that was with us this year. We hope to see you next year in person or online. And we will go and sleep.
Yeah, we deserve to sleep finally.
Thank you, guys.
Thank you.
Bye-bye.
See you.